Good morning to you all, and a very warm welcome to all our visitors from outside. Some of them will be trooping in a bit. I heard the traffic is very bad this morning, but we'll still get started on time. And to our distinguished faculty, including our dean, who's present here, and we expected some more from the BME department. They'll be also showing up, hopefully, in a bit of time. To the students, my fellow faculty in the BioID program. Here is our agenda. I'll give a brief introduction and overview, and following that we'll have 3 of the student team presentations, team 1, 2, 3, and then we'll have a lunch and social event from 11:40 onwards. To get started briefly, I want to talk about the BioID program. This is a master's program, Master of Biomedical Innovation Development. And for those who do not know me, this is myself. I'm the director of this program. So what I thought is, this is where we are housed. This building on the left, the Technology Enterprise Park. It's a very beautiful, brand new, luxurious building, superb facilities, wired and with all the state-of-the-art technologies. And of course, you see the lovely Atlanta skyline there next door to us. So it's in a beautiful part of the city, and we have a wonderful real estate luxury out there in this building for this program. Now, I thought it would be in order for me to give a brief overview of who I am. So I thought a pictorial way is the best way to go about it. I'm really a crass corporate scientist who has led a nomadic life, and I show this arrow pointing towards Wall Street, sitting on my camel, only to convey the point that all my career for 30 plus years, I've been involved in commercialization of medical devices, bringing products to market for global launches from concept stage through preclinical development, clinical studies, regulatory submissions, and product launch. On the lower left corner, you see the first part of my career, I worked on peripheral vascular implants, and the company I worked in literally initiated that whole disease segment, which is now known as PVD, peripheral vascular disease. So we developed implants for below the knee and above the knee applications to save people from the need for amputations. And these are substitute blood vessels. And after commercializing these, life took me to the upper left corner to the cardiac industry, where I worked on implants for close to the artificial heart. We're talking about thoracic vascular grafts, patches, left ventricular assist devices, heart valves, things like that. Again, the company there was a pioneer, which helped me a lot about product for the thoracic applications. And the upper right corner, life then took me to the ophthalmic industry, where I was involved in developing cataract lenses, which are intraocular lenses for cataract patients. When the natural material lens gets opaque and people get old and their vision becomes blurry, they replace them with artificial lenses by taking out the natural one and putting the artificial in. And we developed those artificial implants and delivery systems for those applications. And the lower right corner, you see some controlled release applications which I worked on for central nervous systems, treating attention deficit disorder in pediatric populations, etc. So I consider myself a nomad with degrees in chemical engineering, having strayed in those times to the biomedical area. I used to feel very lonely in this community. Very few engineers were there. Whenever I used to go for Society for Biomedical meetings, I used to be surrounded by biologists and biochemists and immunologists and microbiologists. So those were times when few of us engineers, I was one of the early chemical engineers to have strayed into this industry. And now you can understand, based on this, why my passion is very high for mentoring careers for this industry. And that's why I come here just about 5 months ago to head this program. Now, to talk about the actual program, we convey these domains of knowledge here: regulatory activities based on master's projects, clinical literacy, engineering activities, project management, and electives in areas of chosen subjects. So basically, the students get a very eclectic mix of scholastic training and exposure to all these domains which are required for product development careers in medical devices and allied industries. So I'll go brief back. The mission of the program is very straightforward: to provide master's graduates with understanding of factors in innovation, development, and commercialization of biomedical products, and also to enhance the advancement of medical care, sustainability, and contribution to local economies. With regard to the faculty, I listed here the current faculty who have been involved in teaching. This is the first semester of the program. We're just in the wrap-up part of it, the fall semester. I'm the one here heading this as a director. You see below me Rafael Andino. Rafael is here. He is an adjunct professor in the program. He is the vice president of product development in a local company, Clearside Biomedical, has extensive experience in medical devices. He has worked for CR Bard, Novartis, and other companies. He is a Georgia Tech alum and is an indispensable ally of mine to this program to give a very industry orientation to the whole program. He has helped me a lot with local network and contacts, and as you'll see in the next few slides, how he has set me up and the program nicely for where we are today. I owe a lot to Raphael. And then Jeremy Ackerman, he's supposed to get in here today, but I hope he does. He's our clinical professor from the joint appointment both in Georgia Tech and Emory Medical, and he teaches the course on clinical literacy, which is where he takes the students through all the clinical exposures. And we have Arnie Schneider. Here is Arnie, and Arnie is our College of Business School professor who has taught a course this semester and in a business class, and he's our in-house resident expert to the students and giving them exposure to the world of finance and project costing and accounting and those areas related to business. We have Dr. Ajit Yoganathan, I listed here. He has been associated closely with this program in driving industry outreach and liaison with external resources, and he is literally my academic sponsor with whom I work closely now as part of the recent transition of the BME department. And we have also Julia Babensi. She takes care of her curriculum development aspects and guides me through the academic aspects of the program. I also have Kristen Laquidera. Kristen is there. She is a program coordinator related to admissions and all the policies and prospective student communications. Now, I'm going to show here just what is in the past, this semester in the past 3 to 4 months, the number of guest lectures we had from the local industries and clinicians. I had invited all of them, but due to travel schedules and due to various conflicts, many of them are not here. We are expecting some of them still to come in. But just to list out, Jason White, Vice President R&D at CardioMEMS, David Stern, Executive Vice President at CardioMEMS, Scott Roberts gave a lecture he's from CR Bard, he's the Head of Regulatory and Clinical Affairs. Tom Godfrey also addressed our class. He's the Associate Director CR Bard, in charge of manufacturing. John Gode, he's a Marketing Manager at Bard. Joe Urban, Director of Global Business at Bard. Manuel Kingsley, Director of Marketing at Optical Medical Systems. Samir Kumar Patel from Clearside Bio, in charge of Biomedical Engineering. And Ms. Sarah Koo, Marketing Manager at MD Innovate. Charlie Dignan, Clearside CFO. These are all the guest lecturers who come for all our classes, myself, Raphael, Arnie, and Jeremy. So we listed all of them combined here. And we also have some of the clinicians, Dr. Lakshmi Vaidyanathan, who is an assistant professor in Emory Medical. We have Dr. Philip Prest from Grady Memorial, Stephen Kending, Chief Operating Officer, Solo Health, and again, these two others have already been listed. Now, in addition to these lectures from local industries and clinic who visited the classes, we have some very interesting remote guest lectures from external experts. I would call it remote lectures by renowned experts. That's how I can label these people. Dr. Val Jivanandam is a renowned cardiac surgeon. He has done over 1,000 heart transplants. He does high-risk cardiac surgery. He takes on inoperable cases given up by all other cardiac surgeons. He is the only surgeon on the FDA device panel at the moment. He's an extremely well-regarded surgeon, and he gave 2 lectures to my class remotely from the University of Chicago, where he is now currently the Chief of Cardiac and Thoracic Surgery. Then Dr. Samay Okte, he's a regulatory expert and an ex-FDA reviewer. And he's currently president of a consulting company in Washington area called CardioMed Device Consultants. He's a deep expert in regulatory matters. He conducts on-site regulatory training in major corporations like Abbott Labs and Boston Scientific and Medtronic. And he gave a wonderful talk to my class about the inside stories of regulatory submissions and regulatory aspects, both as an FDA insider and currently as an industry consultant at the moment. Then we have the third person, Mr. Rob Michaels, who is an entrepreneur, a classic Southern California entrepreneur. He's a CEO currently of Cardiac Valve. He has taken 6 companies from ideation through sale to big corporations, the latest being a sale to Medtronic for $1 billion. And he's now on to his 7th venture, where he's the CEO of Cardiac Valve Technologies. He gave my students a wonderful flavor of what it takes to be an entrepreneur. and what are the characteristics needed to succeed, what are the success and failure stories, and all the way from starting from initial investment from the source like 3F, which he defined as family, friends, and fools, to all the way to through venture capitals and getting angel funding and the final rounds of funding and sale to the corporations to make them big bucks. And then we have one more, Dr. Ray Chesser. He was a former boss of mine at Bard when I worked with him years ago. But later in life, he went on to acquire some extraordinarily good training and he's become a nationally recognized expert in Six Sigma processes and process capabilities. He is currently the Director of Operating Effectiveness at Cigna Healthcare. And he came on and gave the students a very nice remote lecture from Connecticut on Six Sigma, process capability, and process control. While on this topic, I would like to acknowledge here Jesus and Stephen Marquez, the IT people, who made all these guest lectures possible for our classes. They worked very hard with these outside folks, set up trial runs, demos, and made it really worthwhile and very, very fruitful for my class. They even recorded some of these lectures. So we are really deeply appreciative of that. Now, there have been some local industry visits and clinic visits also for this class during this semester. I'm just listing out the companies here: CR Bard, CardioMEMS, St. Joseph's Translational Research Institute, Grady Memorial Hospital, National EMS, Family Medicine Clinic, and Children's Healthcare Atlanta. Now, I must confess one thing here. When I came 5 months ago to take charge of this program, I was wondering, what does Atlanta have to offer me for this kind of a medical device area? It's not Southern California, it's not Orange County. What am I going to do here? How am I going to pull it off? Because my interest was only giving practice-based, exposure-based training, bringing the real world in the classroom. And how am I going to do with this few industries in this place? But I'm really pleasantly surprised and totally taken aback by the warmth and hospitality of the Atlantans towards my program, towards Georgia Tech, and whomever we asked for help, they really spontaneously come forward and supported us. That's how I would describe it. And a big thank you to Raphael. He introduced me to several of the local companies, several of the local contacts, and really that helped a lot, setting it up and having them all part of our program. Now they're all aware of our program. We had 2 industry visits to see our Bard. So in one visit, we covered all the functions up to the preclinical from the early concept stage, essentially R&D, product development. Second visit, we covered the regulatory, clinical, QA, and manufacturing. So we have met several other folks. They have talked to us there. And Bard is an established, mature device company, the big company kind. Now, CardioMEMS, in contrast, which is just 3 floors above us in the same building, is a startup company spun out of an idea from Georgia Tech. They have 60 people now in this company. Over a 12-year period, they've grown to this size, starting from about 3 people initially. And that has got a classic startup culture. Now my students have been exposed to both these contrasting cultures, the device industries, the startup kind and the mature kind. And it's been a wonderful exposure, really speaking, to get these 2 facilities in our own backyard. And that's just been a highlight of this program and this semester so far for us. Now I'd like to speak briefly what is unique about this program. Really, I mentioned it all. It's real world industry practices and in-depth exposure to all medical device industry functions. Taking a leaf out of the real estate world where the logic is all about location, 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 I decided to make my program's theme exposure, exposure, and exposure. So the more exposure I can give my students, I believe it will help and incite their passions and drive their careers on productive lines. So based on that, my entire objective was to expose as many diverse elements as possible. And value to industry, we're going to provide them well-trained candidates who are familiar with all aspects of medical device development from the ideation stage through commercialization. And then shorten the learning curve, obviously, for them to hit the ground running. And one of the main benefits that I think these students will offer to the industry is, in addition to taking on technical expertise or offering technical expertise in their domains, they'll also be able to take on challenging leadership roles of cross-functional teams within those corporations as a second hat and give these corporations a very good outcome in terms of leading projects and being a glue between various functions and getting quality products introduced in the market in a timely fashion, which is the essential goal of industry career. Now the key features, I'll just run through this very quickly. We have covered the preclinical R&D is one of the segments where they learn all about concept evaluations, prototyping, and preclinical development using current state-of-the-art stage gate design processes. Then regulatory clinicals, they're exposed to all kinds of submissions to obtain FDA approvals as well as global approvals from different countries for releasing these products. There's a lot of strategic aspects involved in this through case studies, through detailed website information and process knowledge. They've been exposed to all these elements here. And then quality assurance and manufacturing, essential state-of-the-art elements like design controls, process scale-up, validation, Six Sigma, all these have been provided in this course. Now, this is just a brief rundown. In that upper part, the flow chart, this is how an idea flows in the real-world industry, all the way from concept evaluation, where early research ideas are tried out, and then you go into preclinical development, do some animal tests, toxicity studies, establish safety profile, submit for regulatory submissions, then go into human clinicals, and then do the manufacturing validations to scale it up to real-world commercial scale processes, get the final approvals, and release to market. The product development, unique aspects of this product development for the medical device and biomedical products is the regulatory submission part of the clinical studies. That's where it is very unique compared to the rest of the industries. So those are the elements where a lot of different know-how and detailed process knowledge unique to this industry need to be taken into account. And within the lower part of the flow chart, I show the typical functions involved in a medical device industry, comprising R&D, quality assurance, regulatory, clinical, and all the way through business development. The students coming out of this program with all the exposure they have, they can literally walk into any one of these functions. That's the idea, depending on their career path, their interests, their passions. So that's what we are trying to give them the exposure in this program. They can get in, then make their way through and make a contribution in a leadership role. So if I were to define the focus areas for this program, these are the 4 segments: product development, regulatory and clinical, quality and manufacturing, business and finance and marketing. So they can go into any of these careers. Now, just a brief rundown on the enrollment summary for the 2013-14 batch. We have started this program this fall. The first batch enrollment has 10 students, 4 in-state, 6 out-of-state, all domestic. The location is in the TEP building, Technology Enterprise Park building, which I showed the picture earlier. With regard to gender balance, we are nearly looking good, nearly optimal, 4 female, 6 male. And undergraduate majors of these students, 7 of them have come from engineering backgrounds. 1 of them has an engineering plus biology. 1 is a biologist with a doctor of physical therapy, and 1 is a biology background. This is the first batch enrollment stats in a nutshell. Now, I'm going to show this and make a confession. When I entered this industry 30 years ago, as I told you, with a chemical engineering degree, not knowing what medical devices are all about, and me and my colleagues, my tribe, all of us were like deer in the headlight syndrome. And what we hope these students to be when they enter the industry is like this. So with this, I would like to hand over the next segment to Peter Carlisle, who will be the MC for the student presentations event, followed by lunch. And we do hope all of you can, as many of you as possible, can stay over for lunch and get to meet with our students and enjoy the time. Thank you. Peter? No, I need to give you.
Hello, everyone. As was mentioned, my name is Peter Carlisle. I'm
going to get this?
I'm fine.
You're right? Okay.
Oh, you need the microphone so we can record.
Oh, so we can record.
That's why I was thinking.
Let's put it around my time. Gotcha. All right. No, I'm fine. All right. Ooh, sweet, I'm back. All right. Hello, everyone. As Heather mentioned, my name is Peter Carlisle. I'm one of the students in the BioID program right now. And I'm going to be emceeing these presentations this morning. So just as was mentioned before, the kind of the scope of the projects have been kind of project ideation. All of us found a need in the medical industry, kind of found all the backgrounds to that need, what needed to be met, came up with ideas and business plans to move forward, including regulation, business, as you all see there. So these are going to be a presentation of things we found, and just also to mention, but it is kind of like an early stage R&D kind of process, so there is still lots of room for growth in these, but we feel we have a very solid foundation on which to build these projects. So just a brief explanation of how things are going to go. We're going to have 30 minutes, each team will have 30 minutes to present with 10 minutes afterwards for questions. We ask that you please hold all your questions until the question period following each group's presentation. And then if there are more questions you have after that, we do have a lunch following the presentations this afternoon. So if you didn't get to ask what you wanted there or you need a little more clarification, feel free to approach any of the groups at that time. But just once again, please hold your questions until the question and answer period. So with that, I would like to introduce our first group, talking about hip resurfacing. We have Brett Rogers, Luka Krujic, Christina Winsky, and Jonathan Shaw.
Morning.
Oh, microphone.
Yeah. Too many things to hold. That, I don't think it'll work there. This is no good. My shirt bends the wrong way. Doesn't work.
Here, I got it working.
Yes, your shirt's right. It's a European shirt. There we go. All right. So like Peter said, I'm Jonathan Shaw, and I'm going to start off with an overview slide so you know what we're about to talk about. So first we're going to introduce you to a patient population. Then we're going to talk about the solutions offered to that patient population out in the current market, the challenges in those solutions, and focus on one of those challenges into an unmet need. And then we're going to present a theoretical solution to that unmet need in the time frame in which we propose to do it. And so hopefully by the end of this you feel like we've effectively developed an alignment device, which you'll understand in a second what that is, that reduces the cost, length, difficulty, and the patient recovery time associated with a hip resurfacing surgery. And so the femoral acetabular joint or hip joint is a ball and socket synovial joint. And just like every other synovial joint, it is subject to wear and tear or degeneration. And so that process is usually sped up by dysplasia, injury, or abnormal stresses throughout life. So you can see here on this hip, on this side of this patient, you have a good amount of joint space between the two bones. And so that's what you're looking for in an x-ray, a good amount of cartilage separating the two bones. Over here you have an arthritic hip or a worn out hip. And so it's bone on bone with a lot of bone formation around the acetabular joint and the femoral head. And so symptomatic patients will present with groin pain as well as functional stiffness and limitations. And so the primary surgical option for these patients right now is hip replacements. And so, or total hip arthroplasty. So this graph on the blue line here is the projected values based on statistics from 1993 to 2006 on what we expect the market of total hip replacements to grow with. So in 2005, it's around 400,000 surgeries per year in this country alone, then 450 in 2010, and by 2020, it's going to be up to 600,000. In 2030, it's supposed to be around 800,000 or over 800,000 surgeries in this country performed every year for total hip replacements. The red line represents revisions of those total hip replacements, essentially ones that have worn out, gotten infected, or other complications. And so a growing subgroup of that population is the group under 65, and this is the one we want to focus on. These patients typically want to remain active after their surgery, and typically a hip replacement doesn't offer them that. Hip replacements, you can't run, you can't jog, you can't ski or jump. So these guys want to maintain their activity level, and sometimes the very same activity that brought them to have arthritis in the first place. So in 1993 in the United States, 25% of people getting hip replacements in this country were under 65. In 2006, 43%. In 2030, it's projected to be 53%. So it's a growing market under 65 of people who would prefer to stay active after the surgery. So what can these people do? So you can try physical therapy. The average lifespan of a hip replacement is 15 to 20 years. And so if you get it at 45, best case scenario, you're getting another one at 65, and the results don't hardly have the same effect at that point. So you can try physical therapy, strengthen the hip, stretch the hip, basically try to manage dysfunction, kick the can down the road a little bit so you can keep doing the things you want to do without limitation. The second option, or the eventual option, is a hip replacement. So essentially what they're going to do is take the neck of the femur, the head of the femur, and resurface the acetabular socket of the hip joint. So this comes with restrictions, no squatting, because the way they cut into it, at least 97% of the way they cut into it, is going to be posterior. So that's going to be posterior loading so you can dislocate this hip joint. Okay, no running, and no high impact sports, okay, such as skiing, especially mogul skiing. And that's a big topic in out west. So the third option is a hip resurfacing. So essentially here what they do is they preserve the neck of the femur and in part the head of the femur. And so what that's going to allow is increased weight bearing. It's going to be a larger ball and a larger socket, so dislocations are less likely, so you can do squats. And it's a metal-on-metal resurfacing at this point. The theory is that is more durable, and if you look at the long-term studies on it, they do have higher what's called Harris hip scores to age-matched populations to total hip replacements. And so, with hip resurfacing comes a lot of difficulty for the surgeon, however. And so one thing is because you're keeping the neck and the ball of the femur, you have limited ability to correct alignment issues, such as leg length discrepancy or version angle problems. And so if you have a leg length discrepancy or major bone deformity, this can't be performed on you. Okay, second thing is it's extremely technically difficult. The acetabular side is very similar to hip replacement. Okay, you're just basically resurfacing the socket. However, the femoral alignment is a little different. In a hip replacement, you're cutting off the neck, so you don't have to worry about it. Here, you have to put a prosthetic on it right down the middle of the neck of the femur, and it's a neck of the femur that you can't see because it's covered in muscle. And so this is very difficult and unfamiliar to surgeons, so a lot of them shy away from it. And so you have to get the coronal inclination angle correctly and the version angle. And if you don't, what's going to happen is if you go in varus, it's going to cause femoral notching. You can see these two red spots here. Essentially, that's increased pressure on the neck of the femur, and it's going to cause fractures down the line. That's about a 3% incidence in hip resurfacing at this point. If you go to vertical or valgus, you're going to get stem loading and bone resorption in the long term. All right. So the devices they use to align this femur is going to be two main ones. So the main hip resurfacing device out there right now is the Smith & Nephew Birmingham hip resurfacing system. There are other ones, but they didn't manufacture the metals correctly, and they had a lot of what's called metal-on-metal reactions, so they had to pull them off the market pretty quickly. And so, however, this one's done fairly well at 10 and 15 years out. There are some metal-on-metal concerns, and we can talk about that a little later. And so this was approved in this country, FDA, in 2006, or May 2006. And so the market started flooding with these, with Johnson & Johnson and Stryker, flooding with these other devices that eventually didn't do too well. So essentially, Smith & Nephew has two alignment jigs for the femoral side. The McMinn jig, which is the original, the Derek McMinn, developed for pretty much, he was not the father of the surgery, but he brought it to the forefront. And so you'll see a pin in the neck of the femur here, and that's a problem a lot of surgeons have with it over here, is because technically that weakens the neck and could lead to more fractures. So Smith & Nephew's has this spaceship jig where, according to our Smith & Nephew rep, it's about 80% in use with surgeons. Okay? And so this is a very large jig, and this presents a problem because you have to get proper exposure to use this. You have to dislocate the femur a significant amount, significantly more than a hip replacement. So you have to cut away a lot more muscle and make a lot bigger incision. And that incision takes time. And so if you look at the time breakdown of a 2-hour hip resurfacing surgery, it's about 30 minutes on the front end, 30 minutes on the back end, and 60 minutes for the actual installation of the device. If you do a comparison of hip replacements, it's 10 and 10, and then about 50. And so it's a significant difference of just dissection, not even installing the prosthetic. And so you can see the average incision size of a femoral resurfacing is about 15 to 30 centimeters, where a minimally invasive hip is about 5. So it's a significant repair time difference between the two surgeries. And so time is money, and to talk to you more about that is Luca. No.
Let's see.
Right button.
All right, ladies and gentlemen, so I'm going to talk to you about what's most important in society, and that's money. So there are 4 major cost factors for this procedure. We have the hospital, surgeon, device, and patient. These 4 cost factors add up to give an economic burden of $82 billion a year for the U.S. economy alone. So looking at the first cost factor, the hospitals, they first need to classify this procedure. So that they use ICD-9-CM as a classification. So they use 81.51 for hip arthroplasty, which covers both hip resurfacing and hip replacement. And they use 17-41 for hip arthroplasty with robotic assistance. So obviously the hospital is incurring a cost during the procedure. Hospitals actually billing insurance for a cost around $90 per minute. That comes out to $16,000 per procedure that the hospital is incurring in terms of cost. So they file DRG codes to CMS. They have 461, 462, 69, and 70. And 461 and 62 are what we're going to be looking at. That covers a major joint procedure. And the one that we're interested in is the 18,000. That's DRG 462. And so that's without an MCC, so a major complication or comorbidity. That's in our interest. However, if you do have a major complication or comorbidity, then they're going to be filing for $26,000 for reimbursement. An important thing to note here is that not only is the hospital incurring a cost during the procedure, but also post-procedure. For the average surgeon performing the hip resurfacing, there's around a 7-day inpatient hospital recovery. This inpatient hospital recovery is bringing costs to the hospital. And a thing to note here is also that if an elite surgeon that's performing a more minimally invasive procedure, as Jonathan mentioned, with a smaller incision size, this hospital stay is reduced to 5 days. So I want everyone to remember here that there's a varying amount of recovery for this procedure. Moving on to surgeon cost factors. So I put hip resurfacing and hip replacement next to each other for an important reason. If you look at the bottom row, they have the same CPT code. So surgeons are filing for reimbursement for $1,453 regardless of whether they're doing hip resurfacing or hip replacement. However, hip resurfacing takes longer. It takes 1.5 to 3 hours compared to hip replacement that takes 1 to 1.5 hours. So you have the same reimbursement, same amount of money, but hip resurfacing takes longer. There's a higher cost right there. Now moving into the cost factor, we have Smith & Nephew, as Jonathan mentioned, they have the gold standard system, the BHR system. After talking to our sales guy from Smith & Nephew, he told us that it was around $13,000 for the actual system. This actually ranges. There's a pretty wide range because everything's done with individual negotiations with hospitals. But this $13,000 is an average, and it covers only the implants. Smith & Nephew actually provides all the tools for the procedure. After the procedure's over, it takes them and it goes to the next procedure. So tools are basically rented for free. And if the hospital were to want to buy these tools, it would be around $100,000. And this would include hundreds of tools, jigs, retractors, drills, reamers, pins, etc. So lastly, we have the patient cost factor. A non-monetary cost factor is time. The person is taking time out of his personal life to perform this procedure or to undergo this procedure. And also the time of rehab, along with the cost of rehab, deductibles need to be reached, co-payments. And a thing here to note is that if a person is living with arthritis and doesn't perform a procedure or one of the solutions that Jonathan mentioned, physical therapy, hip resurfacing, hip replacement, a patient under 65 is incurring a cost around $3,000, just living with the symptoms. And over 65 is around $2,000. So a quick cost summary. I threw a lot of numbers at you guys. So if we look at the middle column here, these are our fixed costs. These are the costs that don't change. Hospitals billing using their DRG codes around $18,000 and $26,000. Surgeon CPT code $1,453 regardless of the procedure. And the device company is charging $13,000 for their BHR system. But there is one variable cost, and that's time. As I mentioned, there was a $90 per minute cost that the hospital is incurring per procedure. And also, that varying time of recovery, that's that post-procedure incurred cost of, it could be 5 days, all the way up to 7 days, all the way up to 10 days for some patients. So what's the problem? Hip replacement is cheaper than hip resurfacing because of the time, and that incurs higher costs to hospitals. And the additional challenges, as Jonathan mentioned, or the technical difficulty, is that you have to correctly dislocate the femoral head so that you can place the femoral cap on, and the dissection and removing tissue accurately, and that transfers over into our alignment. The alignment device that's used to place this femoral cap, it gives you not accurate qualitative measurements that the surgeon can use. So in the end, the surgeon's actually just going by feel. He finds a spot, and based off the measurements and his decision, he places where the femoral cap goes. And lastly, that recovery time that I mentioned. There's that range of from 5 to 7 days that can be improved on. So that leads us to our unmet need. Surgeons need a cost-effective and accurate device to align the femoral prosthesis
during hip resurfacing that allows for decreased time, which is going to reduce our cost, and improve clinical outcomes in patients. So reduce that recovery rate and allow patients to go back to their active lifestyles as soon as possible. So I want to caution everyone right now. We're going to be taking a leap of faith. We're assuming that we've addressed the correct unmet need and that our company, consisting of the 4 of us, has proposed a solution that correctly fixes this unmet need. So hand it off to Christina or to Brad.
Thank you, Luca. As Luca mentioned, now we're going to move from the ideation portion of this and developing a need onto going into us developing a design and then pushing forward towards our design controls and our regulatory strategy and all that. So first what we took is our need that we developed and turned this into goals that we want our device to meet. We have primary goals. These are goals that we feel that our device must meet for it to be effective. And then secondary goals, which are kind of like things that would be nice for us to pick up, but aren't necessarily necessary for this to be a successful device. So primary goals, definitely to reduce operation time. This is our primary need, so our device has to be able to correctly address this. And we decided to do this through coming up with a jig that allows for a smaller incision size, which I'll go into more detail later. And critical to this is also that whatever our alignment device is, our jig, has equivalent alignment to what's currently available. We don't want to provide surgeons with an inferior device, even if it does save costs, because you're going to have further complications down the road. Secondary ones, improved ease of use. If it's easier to use, it's going to be better adopted by surgeons, but being this is a very technical surgery anyway, it's a pretty marginal difference if the device is slightly easier to use compared to the complications in the rest of the surgery. It would be nice if our alignment device met navigation, which is a system that's currently available, which is based off a computer-aided alignment, and it has the best alignment characteristics currently. So that's kind of the goal that we want to shoot for, but if we don't reach it, that's okay. And then ultimately, we want less dislocations and less further complications down the road. Just superior clinical outcomes. So through this, we started developing our design inputs. As you see, there's a long list of design inputs that have a lot of different categories, and these would have subcategories under them. So I'm not going to go through them all in terms of time, but definitely the main ones that you would know you would have would be the functional characteristics. Does this correctly align the guide pin for the surgery? Biocompatibility, it's not going to cause inflammation to the patient. But you're going to have everything from like human factors. How does the surgeon like how it feels? Are they going to be able to use this one-handed versus two-handed? Will they adopt it to storage and reliability, corrosion resistance? We don't want something that's going to break down before it should. With this, before, I'm going to play a video real quick, and I'll ask one of y'all to play the video if you don't mind. This is a conceptual design that we came up with, but we do feel that this design does feasibly or represent a feasible model for solving the solution. You can see the guide wire is the long rod coming in. That is what ultimately, wherever you place that, that is where the stem for the prosthesis is going to go. So that's the critical component that we're trying to get it properly aligned here. With this, you see that the device works by clamping around the femoral head along those muscles there and uses 2 guide pins, which are here and here. These measurements are taken prior to the surgery based on x-rays. The distance is set. As you can see, these can slide back and forth. So you set that distance, and you're essentially allowing the surgeon to insert this, clamp onto the femoral head, match those up to the anatomical model, and that gives you the proper alignment without the need for a complicated computer system or anything like that. So with this, our key is to decrease incision size. So the key here is the profile that we're looking at. So I'm going to put side by side. We have our device on the right and the current spaceship jig, which is the gold standard, on the left. You see here the profile difference. The incision is going to be going basically up here. So all of this area here has to go into the incision wound. So with the current device, you have profiles on both the top and bottom, whereas ours has about the same profile on the top but lacks that profile on the bottom. This is going to allow for a much smaller incision size
compared to the current alignment device, which ultimately would decrease that surgery time because you're having to cut through less tissue and then do less tissue repair afterwards, and decrease the long-term recovery time during the hospital stay as well. So with this, we started developing testing that we wanted to do during our design and development stages. We just called these design development studies. We have our primary test, which we feel is the one that's most critical, proving that the device actually works and getting feedback from surgeons. Our feasibility study is what we referred to this one as. In this will be cadaver testing to make sure the device does correctly align and do comparison studies with our device to the spaceship jig. And do bring in surgeons to get their feel on it. Do they like it? What changes do they want to make? Will they actually use this device? With this, we also think it's possible we may have to do animal incision studies because cadaver tissue sometimes does not accurately represent living tissue because you lose some of that elasticity. So that would be part of the testing that we would bring in surgeons to consult on that as well. But also testing for material challenges to do the autoclaving cycles, make sure this can uphold through all the autoclaving cycles for 2 years worth of surgeries or however long we want to set it for. Drop tests, all the corrosion resistant stuff like that. Biocompatibility, packaging and labeling challenges, as well as accelerated and real-time agings that would run concurrent, which also help us come up with those shelf life claims. And So now I'm going to pass it off to Christina, who's going to run through a lot of our design controls and our verification validation stages that we're going to run through.
Thank you. All right. So along with those testing that we developed, we also came up with a set of standards. This is not a comprehensive list of standards that we've researched, but our device with the FDA is classified as an orthopedic manual surgical instrument. And so with that, there are ISO and ASTM standards. And for example, the first one here basically helps us with our testing and determining its resistance against autoclaving. And then again, some of the ASTM standards help us for identifying standards of practice for handling these surgical instruments. And then overall, your good manufacturing practices also apply to ensure a quality product in the end. And so with that, we developed our DIOVV document, and that stands for Design Inputs, Outputs, Verification, and Validation. So just as an example, we have up here one of the rows from our document, and for our purposes, we didn't include all of our rows because we have a bunch of inputs. But for this one, we were looking at the user need that we need our device to fit in a smaller incision size. So the device was designed to fit in an incision less than 12 centimeters. And to verify this, that our outputs matched our input requirements, we went ahead and showed that our design development study testing would verify this, the cadaver testing, the animal testing. And then again, we validated that our actual design met the user's needs for more testing. So risk analysis, the purpose of risk analysis is to identify certain functions that might go wrong in your product and to mitigate these risks. So what we looked at was the design itself, the overall design and how it functions. If the user misuses the device, what could happen? Also the materials the device is made of, it's made of stainless steel, and that short-term biocompatibility with the incision. Its sterility and the corrosion resistance in its environment. Also the jig's attachment points on the femur, we did not want it to compromise that femoral neck bone integrity. Also the device-to-device interaction, so how it interfaces with that guide wire. And lastly, its instructions for use and packaging. So again, we took one of the rows from our risk analysis table, and what we're looking at here is that the potential failure mode is that the device does not correctly identify that coronal, the alignment on the femoral neck. So we rated this potential failure mode for its occurrence, severity, and the detectability. And we gave the occurrence for this failure mode a rating of 3, which is a moderate rate of occurrence that we thought this could happen. The severity of this occurring is rated much higher at a 9, because if you poorly align the prosthesis, it could lead to neck fracture in the patient later on. So, and then the detectability, we gave it an adequately high rating of 2. Actually, it's a low rating, but that means that we have a high likelihood of identifying this risk before it actually gets to the user. And we again put up our test that we would do to verify this part of our risk analysis. So the economic value of our device is evident in the money that we can save hospitals. So we targeted our device at a price of $5,000, and this is due to an estimate of around $500 manufacturing costs that we came up with. And then looking at the 30 minutes that the surgeons let us know that could be saved during a hip resurfacing procedure, we multiply the 30 minutes by that $90 per minute hospital billing cost for the OR, and we come up with around a $513,000 annual savings for the hospital. And this is assumed to be 4 procedures per week with 1 surgeon per hospital. So imagine what the savings could actually be, since most hospitals have more than 1 surgeon. So in summary, the jig that we've designed adequately addresses our user need and the problems associated with hip resurfacing. Through the testing and design controls that we went through, we were able to verify that our device effectively has a smaller incision, requires a smaller incision size, which then reduces the time required for hip resurfacing surgeries. So with that, we essentially are able to equate hip resurfacing and traditional hip replacement. And since these 2 procedures are reimbursed with the same codes, this is really important because this can give an opportunity for other surgeons to enter into this space and perform more hip resurfacing procedures that they wouldn't have done before. And in one study, we actually found that reducing the incision size can lead to a shorter patient stay in the hospital, like Luca mentioned. So we're reducing this from 7 days to around 5 at average. So this 2 days saved can essentially save the hospital money. It can increase turnover in patient rooms and also increase the patient's quality of life by having a smaller incision size. So by addressing our unmet need, we've essentially created an economic value for surgeons to enter into this space, and this could actually increase the overall hip resurfacing market in the United States. All right, turn it over to Luca for our timeline.
So everything we've talked about so far as a company would be meaningless without a timeline. So as we went through everything, where our projected launch is in 2016. We have a feasibility for about a year. Our development process is from 2014 to 2016. The design input, output, verification, validation is all within this development. We have design transfer starting a little bit after development, so a little less than 2 years, ending at the same time as development. And we have our reviews, which is basically our gating, just to check mark that we've satisfied our phases. And we have our launch for about a year, and then we do post-market analysis to make sure that our device is correctly performing on the market. So next one. So before I end our presentation, I have this picture right here. So we feel that we're opening up our company to the hip resurfacing market. And also, we're opening up future opportunities to create an alignment device that tackles alignment of the acetabular cap. And with this concludes our presentation. And thank you. Thanks, everyone.
All right, everyone, we'll now open it up for some questions for a little bit. Are there any questions from the group?
Whoever answers.
So, I have a question. For this device that you have here, would you still have to completely dislocate the hip in order to get that jig on there? Because it looks like you almost have to dislocate it more in order to just wrap that band around, I think put the band around the hip socket.
Yeah, you still have to dislocate the hip. You're going to have to do that no matter what because you're putting the cap on to it. So you have to dislocate that whole thing because ultimately you're going to be cutting the bone on that femoral head off. So no matter what you do, even if you came up with a jig that did not require you to dislocate the hip, you're still going to have to dislocate the hip in the surgery. So there's no benefit to.
Right, but then you have to do it more because you have to get that access point around the...
There's an access point on the spaceship as well around the neck of the femur. And so you got to get that access point in. And so in order to get that access point in for the spaceship jig, you have to cut a lot more muscle away. And so the main time consumed is not necessarily using the device. The main time consumed is taking all the muscles off and putting them all back on in the same place. And so the less muscle you have to cut off, because if you externally rotate it 40 degrees, you've got to cut significantly more off. If you internally rotate it 40 degrees, as if you have to internally rotate it 20 degrees to dislocate the hip. And so that's important in this because, and I didn't mention this in the presentation, when you dislocate a hip, you break the main ligament and arterial supply to the bone. And so it's extremely important to preserve as much muscle attached to the neck as possible because that's where the blood supply is coming from now. And so the dissection is significantly more difficult, and that's in part what makes the surgery more difficult for a surgeon because he has to pay a very close attention to the blood supply he is cutting and very, very close attention to the muscles he is cutting. And so that adds a significant amount of time to the surgery. The more you have to cut, the more time you have to take dissecting and the more time you have to take repairing.
Does that answer your question?
So I have a couple questions. First, awesome job with setting up the problem. You guys did a great job. You did a great job painting the reimbursement landscape. That was awesome. And so I'm glad that message hit home. So let me dig into a little bit, not the reimbursement as much as why a surgeon would, why an orthopedic surgeon would like this new technique that you're proposing. So tell me, if you're a surgeon, what is it from his or her standpoint that the spaceship or thing or whatever you're calling it, what problem is it that you're solving that the spaceship thing is not solved? So where are the drawbacks?
Do you want it? I'll take it.
No,
All right, fine. It's basically what we mentioned. It's about the incision size. The problem with the spaceship jig currently that a lot of surgeons are having is they get into the surgery, they go to put the jig onto the femur, and they can't. It physically won't fit in the incision space. So
they have to go and cut it.
then they're cutting more. They're having to compensate for that. They do the other thing, which is to just dislocate the hip more, which is causing more.
The result of that is what?
The result
of making a bigger incision is what?
It's time. It takes a lot of time to cut through all that tissue, especially when you're having to go through the considerations. If you take too much, you can end up causing bone to die later on, further complications. But yeah, you're increasing your operating time.
Okay, so make sure you put that in your final report, the
Absolutely.
time aspect, because that's important. And I really like how you sold us on, if you can save time is money to a hospital and to these practitioners, so that's good. So think a minute about the patient. So if you're this patient, is there a benefit to you as a patient by having what you're proposing over the spaceship?
Yes, it's time in a
Is it like recovery?
It's time in a hospital. Now, there's an argument in the literature back and forth. So there's minimally invasive total hip resurfacing already, or hip replacement already. And so there's an argument already in the literature whether minimally invasive increases clinical outcomes and speeds up recovery. And more literature says that it does for the patient. So you're accelerating recovery in a hip replacement, and I can't say in hip resurfacing because there's not a minimally invasive surgery except for one guy, and that's the guy who invented the whole surgery himself, and he just did it last year. But there's an argument that says that you speed up the recovery from a year to 6 months. So the guy's getting back to sport. Yeah, and it's a short-term recovery. So you're looking at, tissue healing is tissue healing. So 6 months, you can run again no matter what happens. However, if you can walk without a limp and without an assistive device at a month's time as opposed to 2 months' time, that's a huge quality of life increase.
So, okay, so
Wait,
can you
just to add on that. So in terms of the actual alignment, which you were referring to, I mentioned that surgeons, in the end, it goes by feel. So this spaceship jig, they'll use it. Then me and Brett went to watch a surgery. He used it, took it off, and was like, all right, I think I know, and just about put in the alignment.
And he said that.
And he said it, and the sales guy, the sales guy said that this happens with the majority. So if you're getting a hip resurfacing, the doctor is going by feel, not by a qualitative measurement. Yeah. So our device addresses. We said this is conceptual because we haven't, tested it, but it addresses more accurate qualitative measurements that will help you correctly align. So it reduces this feel of the surgeon, and then opens it up to more surgeons.
A real aha moment came when I was talking to the surgeon, and he basically said, he brought me over to his office. He's like, look at this. It's like, I had to put this in without a jig because I couldn't fit the stupid thing in the incision. He had to literally put it in hand. So if I'm a patient and I know that this may or may not be able to align my hip, and this can definitely do it, I would rather have the one that's definitely going to do it.
Right. Okay. So let me. So my last point, and I don't want to hog all the questions, but to your point, Jonathan, that you made, how can you monetize? So think about this. Maybe if you can put this in the report, how can you monetize the recovery time reduction from 6 months to from 1 year to 6 months? Is there a way that you guys can say, because of this new procedure with a smaller incision, there's actually an economic value to that, which is that, this patient's going to be up and mobile and functional in half the time. Have you guys thought about that, or what do you think about that?
Well, it's days in hospital, too. It's 2 days sitting in bed that you're not...
So you could potentially monetize everything you're saying.
Yeah, and I guess that
makes a stronger economic argument for this.
And the rehabilitation costs too.
Right.
So that would all factor into our device price, I guess.
It could, if you show the savings. Yeah, absolutely. You can price it appropriately. Yeah. Nice job. You guys did a really good job.
Go ahead.
I have a few questions, and certainly to start off with, I think very comprehensive presentation, very solid overview. Compliment you on that. I think there are a couple places where, a couple of questions that I have about information that you generated, but also I think there's some places where you could enhance your presentation significantly, and just make some suggestions. First of all, and it has to do with Raphael's last comment, I mean, you identified up front this cost of living with the symptoms. And you actually have a figure of something like $2,700 a year or something.
I think it's 28, but yeah.
I'm interested in where you actually got that figure. And this comes back to the whole issue of if there's a significant benefit after the fact, if you can show what the change is relative to that, I mean, you've got a big factor you could key in on. Mm-hmm. A couple of the other issues that came up is you talked about some of the things that don't show up. You talk about the benefits of your system and the smaller incision, but I think you need to be able to graphically capitalize on that and show. You talked about a smaller rotation required, smaller incision. I mean, those are all key things that don't come through in your presentation right now, other than some verbal comments that you've made.
Sure. Yeah.
Just sort of comparative images that would show size of incision, rotation. I mean, if you're only rotating half, and you talk about the sort of muscle realignment that's required, I mean that's huge.
The reason why we backed off of that was because this is a conceptual thing, and we felt like at some point you're going to start just BSing data and saying, well, we have an incision size of 3 inches, but yes, in the real world, I'm with you 100%. You're going to have to do that at some point. But I do understand. Just because this was a purely conceptual thing, we want to give you an idea that we know what we're doing without just throwing a whole bunch of BS data at you.
Yeah, full thing, we would go into an OR room and look at it and measure in multiple surgeries. It just wasn't possible to get into multiple surgeries at this point to measure that.
But you've thrown those factors out there.
And this comes from talking to orthopedic surgeons. I talked to 3 separate ones. And so
I'm not going to argue.
You should mention what he's saying, though, in your
Absolutely.
final paper.
Sure.
Absolutely.
You've still got some mileage to go. So if I looked at your numbers correctly, you said the hip replacement was like 50 minutes plus 10, 10, and 10 for a total of 70. And you started off with 120 and your saving is 30 minutes. You're still not down to the same time of a hip replacement. So you're still short of that. And you're looking at a beneficial surgery. Anybody that's doing hip replacement is obviously looking at progression on that and improvement. So you're still falling short. And so there's still an issue for a surgeon in terms of it's still quicker for them to do a hip replacement. So this comes back. This is why these factors are so important that I actually just asked you about. Because your only benefit is those factors. You're still at a cost and time differential. But if you can show that the recovery time is faster, and you're convince someone that the damage is minimal in comparison, then you've got a case to make. Without that, I don't think you do. I think you're still going to fall short, and I think you're going to come under really serious criticism.
So you're saying making an argument over hip replacement over hip resurfacing? Okay.
That's part of the argument.
Absolutely, and that's a hard argument to make because the long-term studies on both of those surgeries. Oh, sorry. The long-term research on both of those studies. I mean, these newer hip replacements and these newer hip resurfacings haven't been around long enough to see the qualitative data. Like I said, 10-year data for a patient perspective, the qualitative data, the Harris hip scores are much higher at 10 years on hip resurfacings than hip replacements. So there's a quality of life over a long period of time. But it's going to be one of those things, like I said, the average lifespan of the old hip replacements is 15 to 20 years. Hip resurfacing may beat that by 10 years. So a patient perspective, that's huge, and a healthcare cost perspective. But it's hard to measure.
Part of the argument is to be able to conceptually present that information and show here's the potential benefit over the current system on a comparative basis. And to do that with the images is much more powerful than to say it.
Absolutely.
It's just hugely beneficial.
Thank you.
Excellent. I'm sorry, we are out of time for questions. As I mentioned before,
Steve can. This isn't a question. There's something you might want to think about for the final report. That's risk management on the timeline seems a little optimistic to me. For instance, if there's an FDA certification and our government shuts down.
We're class 1.
Okay, that's fine. So that's good. So you're not dependent on the FDA for this. But the other things are there risks that you can anticipate that could actually cause the timeline to expand that you could actually address in some risk mitigation scheme early on? That was risk management techniques, I think, for people.
I would like to just go into a few questions. Can I get them in? I'm the first evaluators. I don't think my thought I will go last.
I love that you asked him for that.
Okay. I'm going to wear two hats in asking this question to simulate the real world. One is the head of a technical function, such as a VP of R&D. And the second hat is like a member of a management board, where I look at the business side of it. The technical aspects, my questions are, how much smaller incision and what are your goals for generation 1, 2, 3 products? Have you thought through? Like initially, you always have to have more realistically phase 1 introduction, followed by what are your ultimate phase 2, phase 3? Have you thought through those processes? My primary question is, you always talk about a smaller incision, but I've not seen any kind of numbers or any little quantification even. Like, can you give me an idea of that?
We listed out a number in the DIOVV document. We just didn't say it specifically.
So 12 centimeters.
Right. So in that, we're saying we basically want our incision size to be the same as what a total hip is currently.
Your initial generation product, the first product, your conceptual product, do you have an idea how to build off that later product introductions to go, from in baby steps even to more optimal products?
Well, I think with this, what we were discussing earlier is that currently the market is so small for this that you would almost have to be an established company to start it off. Like, you're not going to come in and start a company based off of this. So this probably would be more of a product that you put out in the market to get you into the space of hip resurfacing. The acetabular cup is actually a more critical component to the surgery than this alignment. So that is what we ultimately want to get to. So we want to use the revenue from this to push us into acetabular cup.
Yeah, I want to see your strategic thinking on that aspect. Second question is,
sure.
It be a class 2 or class 3 device with FDA?
This is actually a class 1. Initially, Yeah, initially we were thinking it was going to be a computer-guided system, very similar to what navigation is currently. But the more we got into it, is that current mechanical jigs have similar results, not as good, but surgeons are okay with that. Almost nobody uses navigation, and they use mechanical jigs, including the spaceship one, which we already said is not giving you a qualitative feedback. So this is classified as a manual.
Next question I have is, will this procedure, it looks like to me this procedure very philosophically is like a little bit of a patchwork compared to the total hip replacement, but is there any anecdotal evidence or do you have any thoughts on whether patients who receive this will eventually need hip replacement down the line at some point, and what will be the health economic aspects of that?
So there's two reasons you would get a hip replacement. One is failure of the device. And failure of the device, Derek McMinn, who, like I said, has kind of put this surgery out to the forefront, touts a 96% survivability at 15 years. And so that's pretty good as far as orthopedic surgeries go. Different centers have different survivability rates, and that's largely due to the technical difficulty, and Derek McMinn does more than anybody. That's why his is so high. And that's why we want to get the acetabular devices. The key to survivability, it seems like, is acetabular alignment. But the cost is limiting to develop those things. As far as hip resurfacing to hip replacement, if your hip resurfacing wears out, which the average lifespan is suspected to be around 25 years, even up to 30 years, if it wears out, then you have to convert to a hip replacement. And so that's a fairly easy transition because you don't have to salvage the part that you've already done. You just cut it off. And if you get a hip replacement, you've got to get another hip replacement sooner. So it's the same thing, but you're pushing it down the line.
To Jim's point, those are the kind of things that you can highlight using some numbers and tools and tables and charts or graphs. That would be very helpful for the report as well as for your qualitative presentation.
Mm-hmm.
Just for you to keep
Absolutely. Sure. Thank you.
Last question. This is coming from the ruthless business angle as a management board member. I find your timeline giving 2 years for development a bit too long, and also the process validation. I really would challenge and question that. I don't think any corporation will go and show that much of time for development. You look at this length of time and design transfer and even process validation.
So we're already in the development stage right now, conceptually, right? But we thought 2 years was adequate to make sure.
Yeah, feasibility step. See, my thought is, Raphael, here is where you can also pitch in. Mm-hmm. Feasibility is where you do a lot of conceptual work. And unless there's a semantics issue, development is when you are really come past the conceptual, screened out the concept ideas, started a viable candidate to take it past all the formal preclinical development on which you're going to make submissions and invest in animal studies and clinical studies. That's what I'm used to hearing as development. Unless in this case you're combining a little bit of conceptual activities in the development step as well. What do you think, Raphael?
Yeah, different companies do it different ways. You have to invest the time one way or another. I would rather invest it up front, to your point, Satya, because if the reason for that is if you're going to kill something, you want to kill it as soon as possible. Yeah. You don't want a project to drag on. And once you get into development, you start making bigger investments and you call in additional resources in terms of people and that. And so I would rather spend it up front.
You can make the feasibility a little bit bigger,
a little longer,
more realistic. But in a company with a class 1 device, to go for 3-4 years looks a little too long to me. I work in class 2, class 3, and generally we have done it in 2 years, 2 to 5 year time frame. For a class 1 device, realistically, I'm telling you guys, class 1 device should not take 3 to 4 years. It's a bit odd. Class 1 devices should come under ideally 6 months, 1 year. It's a short cycle.
Yeah, I mean, I think where you guys will have, if you were to do this, I think you'd have a lot of time up front, and then you'd have a lot of time in validation to prove that the device does essentially what it's going to do. Those would be your 2 chunks of time.
Rest of them you have to compress.
Yeah, I mean, if I was to critique that schedule, like the design transfer, that's way too long. So I would put more time in the validation and verification of V&V stuff and a little more feasibility. But again, I realize you guys had a few weeks to work on this.
These are just comments for your.
Yeah.
No, we appreciate it.
You've been working on this for 6 months or anything.
So one thing to note, this structure and everything, it was with the help of CardioMems. This is what they allocated for us in terms of time. Obviously, we don't know that 2 years would be too long. With the advice of them, I put the structure for 2 years for development. Obviously, in your opinion, you think of class 1 would take shorter. Their opinion was that it would take 2 years, but
Companies would work on multiple class 1 projects, and they want them to be real
Yeah,
fast.
so
class 2
Sure.
and class 3s, which are the breakthrough products.
Yeah, so here's what would happen in the real world. So if you were in a large company, you would present this project, and it would get shut down immediately because of the schedule. And the reason for that is that a company would rather take the 4 of you as a resource and put it on a more value accretive project versus something like this, where you will be able to sell it, but you're going to sell this thing and make, you're not going to, your stock price isn't going to go up because of this thing, right? If you're a public company. So what they would do is they'd say, oh, thanks for playing, great unmet need and everything like that, but we're just not going to fund this project. You guys are going to go work on this thing, which has a lot bigger return. And so the key is, without fudging too much, you want to show that you can have this incremental revenue in your sales bag and get this done in a reasonable amount of time, which I agree with at this point, it should be less than 2 years. Otherwise, because you guys are an asset, right? Whether you're in a small company or big company, you're human capital, which is the most valuable asset, and that asset should be deployed to the maximum potential of the asset. So, and it wouldn't be a project like this unless this was made way more attractive. So, if you did everything that you learned in Arnie's class and ran some IRR and NPV analysis and things like that, and had a portfolio of other projects, I would bet you that this thing would be at the bottom of the pile. Not that it's not a good idea, I'm just saying that in relation to other projects that it wouldn't get funded the way you
The
do.
timeline realities.
It's too long. Yeah.
And one of the main benefits we thought of this, if you were Smith & Nephew, is this is not obviously going to be a huge generator for revenue for you. But it could make your hip resurfacing system much more popular.
It'll get you brand allegiance and things like that. But the way this would be done at Smith & Nephew is like, if you're a Smith & Nephew engineering team and you're working on a few projects, they throw this on top of everything else you're doing.
Yeah.
They're like, hey, on the side, you guys go work on this thing.
Fair enough.
That's kind of how they do that.
Thank you.
That concludes my.
What's that?
All right. Good.
Thank you.
Thank you, guys. So up next, we're going to have a presentation from Biomedical, who is going to be talking to us about kidney stones. It consists of Emily Brayman, Natalie Mitchell, and Jack Austin. Absolutely. So who's going first? Who am I handing out? There you are.
No, I have this. It works. We can. I'm gonna stay on the side of it. How do I put this on? Yeah. It doesn't click.
We can just click it ourselves.
Okay, it doesn't.
That's fine. It's just like it is.
All right, there.
What I did while I was in Atlanta.
What?
Oh, that's a helicopter.
It's a helicopter. We went on a field trip. It's fun. Okay, great. It works. Yes.
Maybe you need to put it higher. Let me
Okay.
rotate.
Okay, thank you. All right, we ready? Yep. Okay. Great. Well, thank you all for coming. We are Nat Medical. I'm Emily Brayman, and these are my colleagues, Natalie Mitchell and Jack Austin. And we're here to present to you today a new treatment for urolithiasis, also known as kidney stones. To give you an overview of what we're going to talk about today, we're going to go into some of the background on kidney stones, talk about the market and prevalence, and then address a concern in this field and how we would hope to solve this concern. So first of all, this is a kidney stone, or multiple kidney stones. These kidney stones, like you would guess, are usually found in the kidney and along the urinary system. They are buildups of different materials, and once they block kidney function and impede this passage of fluids, they cause intense pain. It's described as a stabbing in the back, or second to having childbirth. So it's an intense pain experienced by multiple individuals. So today we're looking into creating a new treatment for this disease and addressing some of the key stakeholders in this field. First of all, hospitals. So our device that we're going to present to you today, we're hoping to reduce the amount of readmissions of these patients that have kidney stones to the hospitals, which will save the hospitals money. And not only will it save money to the hospitals, but also to the patients, and we hope with our device to increase their quality of life. Along with the hospitals and patients are urologists. These urologists are the people that work to treat kidney stones, and they, by reducing the amount of readmissions and the reoccurrence of these stones, will increase the amount of money that these urologists are seeing, and the amount of money that the insurance companies are seeing. So by saving time and increasing the quality of life by reducing the amount of readmissions, we created our device called the Stone Jacket, which we will talk to you about today. So to give you more of a background information on urolithiasis, better known as kidney stones, they are found in the urinary system, which is composed of the kidney, renal, pelvis, ureter, urinary bladder, and urethra. And it's a filtering system for fluids. And these stones form all throughout the system, and they build up. They're deposits that build up and can be lodged into the ureters and impeding functions. There are multiple different types of stones, but the most common are calcium oxalate and calcium phosphate, making up 80% of these types of stones, although they can be composed of different materials attributed to different causes of this disease. And there are different types of stones. So later on I'll mention, or my colleagues might mention, staghorn stone, which is a larger stone found in the kidney, or they could break off and or from stones that are smooth or jagged that are found throughout this urinary system. And what causes these kidney stones? Well, it's oversaturation of materials. That could be attributed to poor diets, lack of water, even the environment that you're living in. So being in the South could attribute you due to the dehydration in the warm atmosphere. Also, diabetes and infections could cause different types of stones and materials build up. So when these materials build up, crystals form, and as these crystals form, they begin to grow and collect together, causing stones. And many people have stones and don't even realize it. But once these stones become so large that they impede kidney function, then you're getting that severe pain that I was talking about. So now I'm going to pass it on to Natalie.
Thank you. I'll just hold this then. Okay, so what's the big deal about this, right? So the prevalence of kidney stones has risen 70% in the U.S. alone in the past 2 decades. So it's an increasing market. And currently the statistics for who's affected is that it affects 5% of women in the U.S. and 12% of men. So watch out, guys. And this comprises a total population in the U.S. of 3.3 million people seeking medical care for urolithiasis. So this figure was a very long-term study that tracked the growing prevalence of kidney stones over 20 years. And the big takeaway message from this is that the prevalence has grown in males, females, white, black people, all ages. So it's hitting everybody. So it's not like there's one small slice that's growing. It's everywhere.
another major problem is that we're seeing a severe increase in pediatric kidney stones. And this actually follows along very well with the increase in pediatric obesity. And one of the major, one of the scary figures is the top line, which denotes the 14 to 18-year-olds. So you're getting into an age group that's going to be like entering the workforce. So the more people that are affected by kidney stones are going to be out of the workforce, costing the country more money. So that was the domestic look. So let's look globally, because we wanted to look at this as a global problem as well. It is a global problem for sure. Worldwide, the recurrence rate of kidney stones is 50%. So everywhere in the world, 50% of people who get a kidney stone will have another one in their lifetime. And this graph on the side shows some of the major, the countries with the highest prevalence rates. The top is actually Saudi Arabia. Over 20% of all Saudi Arabian men, by the time they reach age 60 to 70 years old, will have a kidney stone. And a lot of that is actually contributed to the desert-type climate that they live in, because dehydration is one of the major causes of it. And then closely behind them is the Arabic Emirates. And then US and Europe is closely followed behind. So, as this market grows, it's causing some serious direct and indirect medical costs. So the global device market is projected to reach $741 million by 2017. And that's for just surgical management of the diseases, not the drugs related to it either. So it's just the surgical management. This map shows the kidney stone belt, actually. So the yellow shows the kidney stone belt from 2000, and the kidney stone belt is actually the geographical representation of the highest prevalence of kidney stones in the country, which happens to be right along the south. So guys down here, really watch out. The orange and the red colors denote the projected growth of this kidney stone belt in the U.S. over the next few decades, and this is going to cost, obviously, a very high increase in medical costs again. So between 2006 and 2012, direct and indirect medical costs rose from $3.8 to $5.3 billion annually. And actually, the study that did this projection for the kidney stone belt also gave an example that by 2050, Texas, just the state of Texas, will experience an increase of $110 million of healthcare costs for kidney stone management just in Texas. So just imagine how that's going to grow over all the other states and how it increases throughout the country. So now I'm going to pass it on to Jack.
All right. This is working. All right. To learn more about the current devices and treatments, the three of us recently attended Kidney Week, which was hosted by the American Society of Nephrology, and it was just down the street at the World Congress Center. And there we met Dr. Dean Asimos, who is one of the leaders in kidney stone management in the field. And he is working currently at UAB, and he was basically treated like a celebrity at the Kidney Week. And we were lucky enough to talk to him. And the first question we asked him was to give a breakdown of the procedures that he uses, and I'll explain these procedures shortly, but just to give you an idea, he uses ureteroscopy 72% of the time, PN or percutaneous nephrolithotomy 25% of the time, and extracorporeal shockwave lithotripsy 3% of the time. And this is a growing trend among young urologists where they're performing more and more ureteroscopies instead of shockwave lithotripsies, and I'll explain why in a second. All right, the first treatment I'll talk about is the percutaneous nephrolithotomy, and this is a 1 to 2 hour open surgery that's done by making a small incision in the back or side and going into the kidney with a tube. And from there, you can remove the stone, and this is typically done for stones that are larger in size, so over 2 centimeters, and can be done for the staghorn stones that Emily mentioned earlier, where they'll grow into the calyces, and there's no chance to pass them. And the nice thing about this treatment is it completely removes the stone, which I'll go into further in a minute. The problem is it's an open surgery. So typically there's an overnight stay and can be as long as 3 days. So that is a much higher cost for the hospitals. And it's obviously invasive. So there's the risks for any type of surgery. There's a higher potential for complications, infection, creating damage to the kidney and other abdominal organs. So that's why this is, there's some issues with this treatment. The next we'll talk about is extracorporeal shockwave lithotripsy. And this is done in a non-invasive manner and typically lasts 30 to 60 minutes. And it's done by basically pounding the kidney with shock waves. And it works by breaking up the kidney stone through cavitation and direct stress. The direct stress just directly fractures the kidney stone, and the cavitation kind of grinds it up more. And the problem with this is it leads to fragments that can stay in the calyces and basically in a snowball effect grow and recalcify into further kidney stones, which is one of the biggest problems with shockwave lithotripsy. 33.3% of patients had a recurrent stone within 3 months of the procedure. Also, the shock waves cause vascular trauma and damage to the kidney and surrounding organs. And as you can see here, here's an example of 3 pig kidneys that were given the procedure of shockwave lithotripsy. And the first one here is the standard. And each of these were done a few times. And this is the first one with a standard treatment that they give the typical patient. The next one is primed, so it's called the protected. So it has a short amount of shock waves per minute and then gets up to the standard. And then the last one is rate protected, which is done at 30 shock waves per minute, which is a quarter of the amount that is normally done for the standard. So as you can see, there's a lot of tissue damage and vascular trauma. But the problem with doing the rate protected, it takes 4 times as long. So that can lose money for the hospitals. Also, there is a higher risk for serious health problems. So separate from comorbidities, in a recent Mayo Clinic study, they were found to have 3.75 times more likely to develop type 2 diabetes, and these are the patients that received the shockwave treatment. And they were also 1.5 times more likely to develop hypertension. So that's obviously very costly to the healthcare system. The last treatment that is used is the ureteroscopy, and this is done by putting a scope through the urethra and up the ureter to see the stone. And it's also used with a basket that grabs a stone and hypothetically will pull it out. The problem is most of the time the stones are too big to pull out of the ureter because the ureter is only about 3 to 4 millimeters. And so for those stones, they typically use a laser to break apart the stone. So they basically have it captured in the basket and then chip away at the stone, which will lead to fragments, which is a similar complication for the shockwave lithotripsy. And these fragments can travel upstream and sit in the calyce and create a problem with time because some surgeons, like Dr. Dianasimos, will spend up to 3 hours trying to capture all the fragments. So that's a lot of wasted time that occurs with this treatment. And one of the problems is it can only be used for stones less than 1.5 centimeters in diameter. And also, you have to place a stent after doing this procedure. And you actually have to place a stent after doing the shockwave lithotripsy too. And the stent is used to facilitate the removal of the fragments. But the problem with the stent is it causes stent pain, which over 50% of patients have, and some of them even describe this pain as worse than the kidney stone itself. And it's often left in for 2 to 4 weeks, so you can imagine walking around with a stent in your ureter for 2 to 4 weeks isn't the most pleasant thing. So the 4 key problems that we've identified with these problems are kidney stone fragments. So we'd like to remove those because that can lead to a high recurrence rate of kidney stones, which will cost the hospitals money. And also postoperative pain, we'd like to remove the need for a stent and cause that postoperative pain, and to remove further complications, for example, associated with the shockwave lithotripsy for diabetes and hypertension. So looking into reimbursement, you can see here the reimbursements for all the different types of procedures. You can see that with the laser, it's a little bit more, and same with shockwave lithotripsy because you have to be able to pay for the capital equipment of the laser and the lithotripter. And the PN is more because it's surgery, and you're also paying for the ureter stent insertion and removal. So if you take that out, then you would be saving the insurance companies money. And one of the biggest problems is for repeat procedures, you are only reimbursed 50%. So looking at the case of Dr. Dianasimos, who has about 15 kidney stone procedures a week, and he estimates that 20% of these are repeat procedures. So if you take into account the rate at which he does each one of these, we came up with a figure of total cost savings of $50,000 for one physician per year. So this also doesn't take into account the savings of time, because he allocates about 3 hours to each fragment removal for the ureteroscopy, but hopefully ours would to capture it in one fell swoop, which Emily will get into. And this also assumes that they're at full capacity, which they are. So if he would take out those repeat procedures, he could replace them with first-time procedures. So next is Emily.
Great. All right, so what Jack was talking about was the different treatments that are currently out there. But what we want to do is correct the current procedures in the field in order to create better procedures for the hospital, the patients, the insurance companies, and those urologists that I was talking about at the beginning. So first of all, we would need to do a minimally to non-invasive surgery in order to keep up with the competitive market. We don't want to introduce an invasive surgery because that leads to infection. That also leads to a longer hospital stay. So we want to keep this at an outpatient procedure with the less invasive procedure. Also, we want to fully eradicate these stones and stone fragments without being restricted by the size, location, and type of stone. So those types of stones and the sizes, we want to be able to remove no matter the type or size. But also, the key in this is that we want to remove these fragments. So the doctor that we talked to, he did take the time to remove these fragments in order to reduce the rate of reoccurrence. However, a lot of doctors don't take that time to reduce the to get all of the fragments. And if you leave these fragments, you're increasing the number of hospital readmissions. But also you're having to put in stents because the patient needs to pass all of these fragments. And also we'd hope to reduce the complexity of this procedure by easily removing these fragments. So how will we do this? Well, we came up with thinking about biomimicry. So I don't like snakes. I don't know if you guys do, but it is cool what they can do. What they do is they can open their mouths to engulf an object that is a lot bigger than its size. Then once it's engulfed in its body, it's able to fully crush whatever it's engulfing, and no fragments are left outside. So for us, we thought of a similar example of being able to fully engulf a stone, and then while it's engulfed, you wouldn't have those fragments left over in the body. So in interest of time, just going to speed it up a little bit. So the snake's able to completely capture the egg, or in our case would be a stone. And then we would still want to use the ureteroscope in order to be compatible with what's currently out there. But some device that will enclose the stone while crushing it like the snake does by pressure. So we looked at multiple user needs. We came up with over 30, but here are a couple that we selected as what we want our device to have. And so we want to make sure that it's compatible with the scopes that are currently out there. We don't want to reinvent the scopes. We just want to create a device that is compatible with them and the urinary system. Also, we want to make sure that the capsule material is able to withstand however we decide to crush this stone, and that we can actually crush it while it's engulfed in the capsule. Also, we want to remove the need for the ureteral stent, like I mentioned, because we would reduce all these fragments in one procedure, as opposed to the shock wave where it just breaks them up and then has them pass, or for ureteroscopy where it breaks them off with the laser internally and then the chips are left. Also, by reducing the stone fragments, again, just to reiterate, this would decrease the rate of reoccurrence because these fragments build up into another kidney stones. And so we came up with 3 different ideas for crushing the stone by heat, chemicals, and pressure. And after doing a risk assessment, we decided to that chemicals was the least feasible. So what I'm referring to with the risk assessment is this chart. And so we had a list of over 60 risks. and broke them up by topics and then what the different hazards would be, as well as the situations that would cause these hazards and the effect of the situation. So I just selected 3 of these as example of one breaking up by heat, breaking up by chemicals, and breaking up by pressure. And then by determining the difference by occurrence, severity, and detectability, we determined that chemicals escaping the system would be hard to detect, and also it would be damaging. It could potentially damage the system. So this actually had the highest risk priority number of the 3. So we came up with the possible ideas, and this procedure is used for gallstones. So we actually looked at what's currently out there and how we can modify what's out there to apply it to our system. And so what they do for gallstones, well, gallstones are made of cholesterol or cholesterol-based as opposed to the calcium oxalates that kidney stones are typically made up of. So they are able to be crushed just with the nitinol wire basket. Our idea is to create a drill bit on the end of our catheter. This drill would break up the structural integrity of the stone, and then a sheath would go over the stone. So when it's crushed by the nitinol basket, similar to what they do in gallstone procedures, the drill would be able to break down the integrity so it could be crushed, but then a sheath would go over this material so you don't have these stone fragments left in the body. Our second idea, we actually looked at a totally different type of field, is cardiovascular. So what they do for this is when they have plaque buildup, they actually go in with a balloon to remove the plaque buildup. So we thought of using a similar object. Obviously, this would be in the ureter or the kidney. And you balloon out, and then actually the stone would dissolve by laser or some type of dissolving mechanism. And then it would suction in these fragments. So we actually ran this idea by a doctor, and he liked the idea of being able to vacuum out the stones so you don't leave those stone fragments in the body, and you also don't have to spend time trying to get each one out. So overall, through these 2 solutions that we came up with, we would hope to reduce these stone fragments by removing, and also by removing the need for stent. You would no longer have buildup of stones, which decreases the rate of reoccurrence and the readmissions to the hospital, and you don't have these post-operative complications that we discussed with shockwave lithotripsy, such as an increased rate of hypertension and diabetes and vascular damage.
Okay, so moving forward, obviously we have to do a little more assessment for which one of these 2 seems to be the most feasible, and that would be back to back to the bench testing on what would be able to actually break the stones, because that's something that we still have to look into. But moving forward for regulatory and reimbursement, we've identified that we would be a Class 2 device, and that we would qualify for a 510(k) submission for the FDA, as this device would be very similar to the current ureteroscopy procedures and products out there that are currently being used for this. Also, we wanted to look into CE mark, and we think we'd be a Class 2A for looking into the European market. And as far as reimbursement goes, the CPT codes for ureteroscopy with the laser, we think that our product could fall under that code, and we wouldn't be able to just follow along in that regard. Moving forward into clinical testing, as far as looking into the animal models, the most commonly used for kidney stones is porcine, because their urinary systems are the most similar to humans. So we're thinking of using a porcine model to at least assess the safety of the device, and at least be able to know that we could successfully remove the stone from the system. The pigs are typically fed HP, which is a high oxalate diet, and that helps form the calcium oxalate crystals in the body, which are the most common that we'd be dealing with. And then along the lines of clinical testing, even though I had said that we'd be a Class 2 device under a 510(k), we'd probably still have to do some sort of clinical testing to show efficacy over the current products, particularly assessing, maybe doing a test that would be randomized, assessing people being treated with our device versus the current ureteroscopies with the lasers, and seeing how that we actually remove all the fragments fully, and maybe even a long-term scale to see if our device actually reduces overall recurrence rates completely. So we feel that our device could benefit all 4 of these major stakeholders: the insurance companies, the urologists, the hospitals, and the patients. For the insurance companies, we'll be reducing the recurrence rate and readmissions rate to the hospital and minimizing the complications, as well as the major complications that can result from ESWL that also leads to even more healthcare costs down the line. And it would save the cost of the ureter stent, which is $154 per procedure, and that's for both ESWL and ureteroscopy. And that's just for removing it. And for urologists, we'd reduce their operation time. Like Jack said, Dr. Asimo said that he could spend up to 3 hours just trying to remove fragments. And we could increase their reimbursement rate to over $428 an hour for a common ureteroscopy, rather than just a little over $100. For hospitals, we'd be saving the loss of the repeat procedures that occur, which would be about $900 per ureteroscopy, $1,800 for ESWL, and $1,600 for percutaneous nephrolithotomy. And for patients, we would be improving their quality of life, as they would hopefully not have as many recurrent stones, and that's always great, as well as no necessary stent. So they wouldn't have to deal with walking around with a stent for 2 to 4 weeks after this already painful ordeal. It'd be an outpatient procedure. Hopefully that would impede their lives less and less, and they'd be able to get back into the workforce and reduce risk for complications. So at this time, we'd like to acknowledge the following people for help throughout this whole semester, and open the floor for questions.
So let me throw a couple out. First, great job, and I really like that you guys sat down with the urologist. I mean, that's really the key, right? It opens up your eyes when you sit down with someone like that. So I'm still unclear what exactly is the unmet need and the proposition that you're going after. Is it that you're trying to reduce the presence of fragments in stones that are already that you're going to remove, or is it that you're just trying to do a better job at removing the stones in the first place?
It's removing the stones in the first place completely, because the problem is someone has a stone, they go and have one of these procedures, and fragments are left behind and often don't pass, and then they recalcify and form more stones.
It's complete removal.
Yes, fully eradicate.
Okay, what you said there.
And we saw with the percutaneous nephro, they fully removed the stone, and that actually has the least amount of recurrence.
Right.
So because they completely removed.
But it's an open procedure.
That's super clear in your paper. So
okay.
The second thing, and we talked about this the last day of class, was so what is the estimated margin? In other words, the difference between your cost of goods and the CPT reimbursement amount for the codes that exist. What do you project is that? So out of which of these buckets would your device be reimbursed, and make some assumptions, and if you don't know it now, put it in your paper.
Okay.
Really for all you guys, for all 3 teams, because I'm going to be looking for this. So does this project make sense to do, in other words?
Okay.
Is there like a margin that is sufficient? And remember we talked about in this industry, you need to have a margin of at least 60, 70, 80% for the project to be viable. So given that, like where would this come out?
We feel like this one.
Like the 1496?
Yeah.
So,
these
the
ones.
1496 goes to pay for what? For the product or for time?
This is for the procedure.
For the procedure. Out of that 1496 is the hospital. Do you got to pay for the hospital's overhead?
So the hospital is for column what?
These are the hospitals, and this is the MD itself. So this is how the hospitals get reimbursed for the procedure, but from their insurance companies, and this is how the doctor gets reimbursed.
Okay, so I want to see something in the paper about, like, you know, this is economically viable because of this. Because this is, if it's the 1496 that you're going to use to pay for your device, is that what you're saying?
I think so. Yeah.
Make sure both.
It would be all of them.
Well, yeah, it would be
So the hospital
depending on where it would be.
reimbursed one column.
Oh,
And
I
then
see.
the medical doctor,
A
that's
and C
the
is
part
what?
that they get.
This is ambulatory service care center.
Okay, so outpatient.
And then this is outpatient hospital procedure.
Got it.
And then this is in-facility doctor,
But
because
I
they
would
don't usually
tell
do
you
it in the
that
office.
2593 and the 1496 includes everything. Includes
Right.
doctor's time, nurse's time,
Well,
overhead.
The doctor gets paid separately. So they
428.
get
The 428 is for the
He gets
doctor.
paid
He
squat,
said
yeah.
400 to 600 was his
Okay.
range.
So just, it'd be good to do like a little analysis on that
Okay.
in your paper, just to show how you're gonna make money, because if you don't have that margin, and make some assumptions for your cost of goods. If
Okay.
you don't have that margin we talked about, remember what I said, this is a dead project. There's no point in doing this thing, because this has already been set for you. So you know
Right.
the answer, you know you're gonna have to get paid out of one of those two buckets.
Right.
Okay, I got a lot more stuff, but I'll leave for other people to ask. Questions?
I'll go last.
You can go now.
Yeah, my question, I don't understand how your laser uroscope with suction is different than the ones that currently exist. I mean,
There is not a suction
there's
for.
not, it's on the market, but I mean, like all I did was Google it, and there's like 18 patents. Like, I mean, this has obviously been looked into, so I don't understand, like, if there's patents there, that means somebody thought it was a good idea.
Right.
So maybe look into why that was not pursued.
And one that we were
Or maybe
thinking,
it is being pursued, it just hasn't been approved yet.
one that we were thinking is there's only 2 slots in the current ureteroscope that you can put the basket through and then the laser through. So you have to be able to hold the stone and then laser it off, and then ideally the vacuum would suck those fragments coming off. But then that would be 3 devices in there at the same time, and there just may not be enough room in the ureter. So we're thinking about something that does it in one.
The device, one of our biggest issues is real estate. So we're working in such a small area we're trying to keep the scopes compatible. So that is one of the.
And are you trying to get the stones in the calyces of the kidneys or in the ureters or both?
Ideally, but
It may be harder for staghorn because sometimes they grow into the other calyces and they're literally like, you can really only do it with percutaneous nephrophthalmotomy, and those procedures can be crazy. You could have like up to like 10 access points in one kidney. And that is kind of out of our area. Those are really rare too.
I have a few questions, comments, and something probably apply to all the teams. One is, first I'll make the comment, there's a mindset thing for all the teams. I just want to suggest, even though in today's world, economics dictates a lot of our thinking, I just don't want people to lose out on the innovation aspect, because I don't want, I know that we have to keep the economics in mind, we have to keep pricing, insurance, those are the realities. But at the same time, there's some breakthrough ideas. Let's have a mixed bag in our portfolios as part of our thinking, because there's something extraordinarily good, innovative idea breakthrough. Even if it costs more, one can eventually convince the insurers and the society that it will have long-term benefits and the numbers can be worked out. So keep that in mind. That's what I'm trying to keep that in perspective, because all of us, including me, last few years, we've been so overwhelmingly going towards the economic aspects that I think the balance has swung a little bit more that extreme. So let's not lose out on our innovation. Let's keep our innovation hats going. That's just a general comment to all the teams. I do know that we have to reduce hospital costs, we have to reduce incision size, we have to reduce product costs, everything, we understand that. But let's not go overboard on that alone. If there is some breakthrough material, breakthrough design, let's keep that pot also boiling. And we can have a mixed bag of long-term, short-term, medium-term projects. That's the reality of life. We can keep that perspective. But with regard to your team, some of the questions I have you considered a drug-device combination? I know you have a laser plus device here, but what about a drug-device combination as a possibility, as a concept? Is that something?
That was originally one of our ideas, as that was part of like the chemical combination. But we thought that being a combination device, it may be harder to find something that, if it did leak through the material or something, finding some sort of material compatibility, so like we knew it wouldn't have any effect on the material and be able to leak out into the system, because we wouldn't want to have any type of problem with that kind of issue. So that's one of the major reasons why it was removed during the risk analysis, but that was one of our original ideas.
Mm-hmm. Also, our expertise is more in mechanics as opposed to pharma.
Yeah, I just want to make sure that that thought process built.
But if you have a chemical that can do that.
And actually, one of the funny things that we were finding, because we were looking into like the mechanical properties of the stones, and that's what led us down the road to knowing that obviously they were different than gallstones. You'd have to impede their structural integrity before you actually broke them the way like a gallstone would be. But actually, the pH of the urine affects how hard the stones are, and like a more basic pH makes them easier to break. So that was also something we maybe were thinking of in like almost like a pharma type thing, where like reducing the pH of the environment of the stone before you break it. But that's also along the same lines of don't really know what would happen to the system if you reduced.
Yeah. The other thing I want to ask is this device, with all its applicability and its disease incidence all over the world, I think calls for a global thinking with regard to usage. And have you thought of low cost application, global settings across Africa, Asia, and that's now a big thing for many medical devices, to develop low-cost solutions for the worldwide global markets, but eventually it comes back to benefit US as well with the insurance industry going on here. So that is something that, you must have probably built in strategically into your thinking in this activity. The other thing I want to ask is, you mentioned Saudi Arabia, UAE has very high incidence of this disease. Have you, in your clinical studies that you plan, do you have Saudi Arabia enrollment? Do you have those centers as a country to test out what might be the difference between those countries where it's very high prevalence versus other countries compared to other countries? That's something that clinical studies may want to plan out. And likewise, I also want to ask, is there any race-related things? Is there any literature saying that the locations, the hardness, the size, where these stones are formed are tougher in Japanese versus people in Iceland versus Saudi Arabia? This happens in many other applications. Is there anything that...
when they do the breakdown by race, the highest prevalence is in white males, and the lowest, I think, is Hispanic. And then African Americans kind of in the middle, but I think it has more to do with the environment that they're living in.
The lifestyles, there's a lot of things going on here.
It's like lifestyle and where they live. Like I said, Saudi Arabia is like in a desert, and like the belt line in the country is where it's like the hottest also. So I think a lot of it has to do with the location actually and the lifestyle, and it just happens to be in demographics because of where people are living.
Finally, one thing I have to ask this because I'm would be a ruthless board member, question your existence. Where's the timeline? I don't see a timeline.
We're still in the beginning phase.
But conceptually, a timeline. We need a timeline. Without a timeline, life doesn't make any sense in the real world. So I'm just letting you know for your report at least.
Yeah, sure.
Please do build in a timeline and as close to reality as possible. That's all I have. Thank you.
Thank you.
So I'll tell you guys, having worked in this field, and one of my teams launched a laser ablator that you're talking about, so I'm very familiar with this space. The idea you guys have of using the snake as a biomimic that's a really good idea. I'm just telling you that. I have not, and we searched the patent field pretty extensively, and I don't think we came across anything like that. So you guys might be onto something. Yep. So.
Raphael, as you all know, just to introduce the rest of the audience, insights and expertise in mechanical design. These comments coming from him.
Yeah, so that's a really clever thing. And so when you show the snake, when you show the snake with the egg, that's a really clever idea. Now, making an inanimate device do what the snake just did in the picture there is not
So that's the mouth, and we need the sheath to be the body.
But if you can do that, that's a really good idea. You'll get a lot of urologists excited.
So now you're saying it's all, whether it's a python or a cobra.
That was our original idea.
That's a really, I'm just saying it's really clever.
Thank you.
We were just worried about the properties of the stone and how easily it would be broken. Which is why we thought of the drill bit, just to...
But there's ways to do that, I think. But that's clever. I've not seen anyone propose an idea like that. You guys, that's a good idea. I'm just saying.
And beware of your IP position. We talked about that.
No one's stealing.
So whatever you go about, please guard it and keep that in the back of your minds.
Did we find out? So if they come up with stuff like this, obviously they have. What's the position for who owns the IP? Is that the institute or is that the students? Do we know?
Well, I talked about that. In most of the academic capstone knowledge, James here, we talked about it. It belongs to the, it will come to the part of the, it belongs to the team and the university will get assigned, as far as I know. Julie, any of you?
And you have to assign. I'm not sure what the final agreement was for BioID, but yeah, they were using some design as
But if it's sponsored from, if it comes as a sponsored project from an industry, then the industry will have ownership. But if it is not sponsored, if it comes up on their own, then we'll have to go through the university lawyers. That's where we have got this far.
So what exactly does that mean? We don't know. We just have to.
So we don't have a
So no one tell anyone your ideas.
Yeah. So don't expose.
It's a case-by-case basis at the moment, but we are trying to develop a uniform policy on that. I'm in discussion.
So Seth, I've tried to sort of track this down a little bit. My understanding is that if it's an in-class project, it's owned by the students. If there is,
and assigned to the university, assigned to the school.
You can assign, or at least my
Or so
understanding, you can personally assign it if you want to.
If GTRC is interested in it.
You can, yeah, that's an option, if the students want to do that. But my understanding, it depends. So I'm not sure how you're handling, whether the issue of sponsorship is a bit of an issue. So is that a foundation type grant that comes in on no strings attached, and it still belongs to the students? If it's actually, if there's a legal agreement up front, then it's a different case altogether. But normally you don't do that in a in-class scenario. So
I think they should also be putting together mental disclosures.
Yeah. So all this is just emerging, so we're going to address this as we go. We've been talking about it.
I would do that.
So
any of the teams, disclosure would be a first thing to do.
It's a no-brainer.
It's just a recording of the ideas in the lab work for emails.
So in the IDME classes, and I think in the ME capstone project, the students are free to negotiate directly with the company if there's a sponsor.
And do you know, if you have
We've had cases like that.
If you have any information on the policies and procedure aspects of it, you can pass on to me. I can.
Historically, there was a policy that Georgia Tech claimed that they owned everything, and that was shot down in a national judgment in California, and they basically flipped it over and said that in-class projects or students belong to the student.
Wow.
That's my understanding. I mean, it could possibly vary from school to school, but
I'm gathering inputs on the subject right now. I'm not yet.
It should though, right? It should be the same across the whole university.
Thank you.
We'll address this.
Yeah, I'm just saying, you guys know some smart people, so if you want to take that further, I would encourage you to.
Thank you.
Thank you.
Thank you. So, last but certainly not least is my group. We'll be talking about age-related macular degeneration and an interventional therapy thereof with my teammates Shauna Hagen and Sven Moon and myself, Peter Carlisle. So we'll get this loaded up and then get right to that.
Is it at all possible to move this to here, or is it too far out? Just so that we can. On the computer. Just so that we can.
If it reaches,
I got it here, but if you wouldn't mind, just kind of.
If it doesn't, don't worry about it.
What are you doing? It's fine.
I was just saying if it should everybody.
So while we set up, good afternoon, everybody. I know that we're running into lunchtime. Sorry about that, but don't worry. We'll keep you entertained. They save the best for last.
It has to be up. All right. Sure. That one's good. Yeah. Thank you.
Excellent.
All right. So my name is Sven Moon, and we will be talking about wet macular, age-related macular degeneration. I will be covering the anatomy and pathophysiology of it. Peter shall be talking about the market and trends that go along with it, and then Shauna shall be finishing up with our solution and and our strategy to bring it to market. So, first of all, just before I get going, we'll leave it right there. Surprise. Before I get going, I'd like to say that I do actually have a grandmother with age-related macular degeneration. And it's a terrible disease. My grandmother is 89, but she's a lively 89. She actually lives on a farm, and she tends it. She works the cattle. She has a garden. But when she was diagnosed and then ended up fully confronting bilateral AMD, and she could no longer see anymore, all that was taken away from her. So the human effects of wet AMD are actually quite profound because they really take away your ability to be yourself and do everything that you've been able to do your entire life. With that, let's start off with understanding the anatomy of it, which goes into the pathophysiology. So it's important first to understand the eye. And here we have the eye from the outside in. That outer layer, the white one, is called the sclera. It is a tough layer, and just above it is the choroid space. This is a vascular layer that gives nutrients to the eye. Just above that is what's known as the Brooks membrane. That separates the choroid layer from the RPE, which is the retinal pigmented epithelium, which is incredibly important to the eye because it ferries nutrients and waste from the choroid space into the to the photoreceptive cells, which of course are responsible for our ability to see. And without it, the photoreceptors die. Now, the highlighted portion here, as you can see here, is where light focuses in on the eye. The most light that is responsible for your central vision, that is recognizing somebody's face, or being able to read, or being able to drive. It's all focused in there. And as a result of this light, the choroid space is subject to a great deal of stress. And as a result, over the course of time, there's a great deal of inflammation that occurs. And as a result of that inflammation, angiogenesis factors are released. And this is a vaso-endothelial growth factors, something that we lovingly call VEGF. It's released into the choroid space, and normally, this is fine for the body. It's all over the body, for creating angiogenesis. But when it's overly produced, especially in the eye, what will end up happening is that small vessels will actually start to break past the Brooks membrane, which wouldn't be the worst thing in the world. But unfortunately, these new vessels are leaky. And what will end up happening over the course of time is they will leak fluid and even blood into the Brooks membrane just below the epithelial cell lining. And then as a result of that, nutrient transfer cannot occur. And so the RPE dies, and then as a result, the photoreceptive cells die. And that, again, is in your very central vision. So eventually you go blind. And at some point, this becomes irreversible. And to give you an idea of how quickly this can happen, I didn't know about this. I was talking to my grandmother, and she was relating a story from somebody in her Sunday school class. She had been looking down and washing the dishes, and then she looked up out of the window, And all of a sudden, as she looked out on the field, a veil of red actually came across her vision, and she could no longer see out of one eye. So, let's see. So that's the primary physical issues. Now, the costs of AMD are unfortunately large. As we see here, the main way that we're fighting wet AMD right now is through intravitreal injections of anti-VEGF. That's stuff that causes angiogenesis and, of course, the leaking into the eye. As you can see, the actual cost of doing the injection isn't all that large, but then we also have the cost of the drug, which in the case of Avastin is low, and as a result, Avastin is generally prescribed about 70% of the time. In other cases where the disease has progressed to a point where the VEGF, the anti-VEGF, isn't quite enough, they will do other therapies such as laser therapy and here photodynamic therapy, which actually laser ablates out the vessels that are currently in the eye and producing problems for the retina. But as you can see at the top, we're looking at a total of $575 million yearly for the United States alone. And when we look at the global impact, it's even greater. The total there is $255 billion in direct costs because of AMD. And this is actually pretty persistent. The persistence of cost is fairly. It ranges throughout the world because some countries don't deal with it as well. Some countries deal with it a lot better, such as Australia. But even our friends in Germany have a larger price tag to the country than us. And on an individual basis, it costs the patient quite a bit of money, $22,000 a year for shots of Lucentis, which help with the disease. And unfortunately, the reason that this is such an important space is because of the baby boomers. This is going to be a much larger problem very soon. If we look over here at the left-hand chart, we see that the prevalence of AMD increases steadily up till about the age of 70, and then it spikes highly for both men and women. Over here we see projections for our baby boomers, and just to give you an idea of how big a deal this is, those under the age of, the 2010 census showed that those under the age of 18 only increased about 3% worth of growth rate. Those above the age of 65, because we're doing a better job taking care of people and making them live longer, their population increased 15%. The worrisome thing is the people that are coming into that same age group within the next 10 or 15 years, which is the 45 to 65-year-olds. Their population grew 31%, 10 times that of the 18 and unders. So this is a very big deal once you start multiplying these graphs together. And you see that by the year 2020, we go from 1.8 million to nearly 3 million in incidence. That's fairly close to doubling. And that's just at 2020. This line right here shows 2030, where the increase is still even larger, and that's going to continue out till at least 2050. So that wouldn't be such a big deal, except that those treating AMD are stagnating. The amount of ophthalmologists in the United States, here we can see per million of the population, we only have 81, and we're doing better than most countries. So worldwide, this is a problem as well. And here we see that our total increase for any given year is about 140. If you take that out to 2020, you can see that there's barely any growth at all. So who's treating all these people? It's a good question. And unfortunately, it's not that all 25,000 ophthalmologists are working day and night on AMD. Here we see ophthalmologists there. Only about 2,700 of these are actually retina specialists, which are the people that can give intravitreal injections. And of those, only about 2,200 actually do. So we're talking about a very small population dealing with that isn't growing any, dealing with a population that is growing like crazy. So just to kind of put that into measurable terms, just out to 2020, and it gets worse after then. Here we have the increase. Here's the ophthalmologists available, but here we have the ophthalmologists that are actually treating, and we're looking at a 50% caseload that is already strained. How strained? Well, my grandmother, when she went in for treatments, they did her workup and everything, and they said, okay, well, we do need to do these laser ablations to get the other vessels out of your eye so that you can see it all, and we need to do that immediately. How fast is immediately in the current market? Took her 3 weeks. Peter?
So that's the problem we're currently facing. So now to talk a little bit about what. Oh, yeah.
Be heard.
So now to talk about what actually it is that is done. So as you heard Sven mention before, the current treatment is an injection of anti-VEGFs to help counteract the angiogenesis occurring in the back of the eye. Now, this is done through an intravitreal injection, and how the process normally goes is the eye is opened with a speculum, the entire area is cleaned using aseptic techniques, and a needle is inserted into the eye 3.5 millimeters posterior to the limbus, which is this little line right here, right after your iris, and injected at just about a perpendicular angle, slightly increased, about 12 to 28 degrees off. And so this location is very important because when you inject into this location, you are behind the lens and all the muscles that control the lens, but you are in front of the retina. So the needle being inserted in this location has the minimum chance for damage to an ocular structure. This procedure usually takes about 15 minutes with aseptic techniques and the injections, and can only be performed currently by an ophthalmologist with the specialties that Sven mentioned. So, but it's an outpatient procedure, about 15 minutes, and that's how they get it in. Now, the three most common drugs that are injected are Lucentis, Avastin, and Eylea. Both of these, Lucentis and Eylea, are approved for use in wet macular degeneration. Avastin is so much cheaper because it's an off-label use of a colon cancer drug, which does somewhat of the same effects, however, can be injected for a lot cheaper. But in general, injections are fairly effective in slowing or halting wet AMD. It's a fairly quick procedure with a fairly low complication rate, especially compared to its success rate. However, all in all, it is a very expensive procedure. Some of these people need you need a monthly injection. Sometimes you need 20 injections on average to treat it, but some people need a lot more. Some people need it for the rest of their life. And as the slide earlier mentioned, the total costs for a patient being treated with this are about $22,000 per year. Now you extrapolate that out for people who need this for years and years and years, and that cost just exponentially grows. So there's a lot of stakeholders that are currently involved in this. We have the doctors who, as Sven mentioned before, are finding an increasingly large burden upon their time and upon their practice. And as we mentioned before, there's even this just kind of this small, narrow field of people who are doing this, and they haven't necessarily hit it now, but as Sven mentioned, they're going to. But their time and their value is to be greatly considered. But also is considered is the patient themselves. The patient wants a procedure that's first of all going to be effective for them and that's going to be comfortable for them. I mean, it's an ocular injection. It's not an easy thing to happen. And so anything we can do to reduce patient discomfort and any risks to them is of the utmost importance. And also to the caregivers, family members, people who take care of these patients, because as Sven mentioned, people just completely lose their sight with this, and it's a very burdensome thing. So the best thing that can happen for all three of these people need to be considered by us. So with all of that, we've come up with the need statement that in order to meet the rising demand for intravitreal injections, ophthalmologists require an assistive technology to mitigate the increasing time and patient load. So some companies out there are already kind of acknowledging this, and here are pretty much two of the current technologies. We have the Invitria injection guide, which is placed into the eye and has an injection guide there. However, as you can see, it is a fairly bulky thing, and one of the things we talk to with ophthalmologists is that the less patients can have around their eyes or up close to their eyes, the better for them. So that's it's not a perfect technology. And over here we have Clearside Biomedical's suprachoroidal space injection needle, which has been considered for treatment of VEGF to inject in a, so you don't go entirely into the eye, you just kind of inject into a layer of the eye and possibly. However, neither of these are currently on the market. The one on the left is being marketed in the UK, and it's been used about 2,000 patients. Not a lot of studies have been shown, and Clearside is still in R&D. And so we have come up with an injection guide. So this was our first guide. We just wanted something that would be placed on the eye that would help the ophthalmologist or a caregiver with the injection, and has evolved to this. So this is our current design idea. It is a low-profile injection guide that is placed upon the eye. So as you mentioned before, low profile, so the patient doesn't even notice that it's on their eye. It doesn't see that it's on their eye, which helps them with kind of the anxiety of something like right up front. And how it works is it's a fairly strong material. We're either going with PMMA or PTFE. And so this material is flexible enough so that we can place it on the eye and secure it to the eye. It can conform to the eye's structure. However, it's strong enough that if you try to poke a needle into it, it won't pierce it. So in order to get the needle into the eye to where it needs to be, we have an injection slot. This slot is the size of a 30-gauge needle and allows the caregiver to insert the needle in the correct location and at the correct angle. Both of these helping reduce any of those complications that I talked about before of finding this ideal location for the injection. So this helps to standardize the procedure, and it helps to lower any risks of kind of improper placement. So in construction of this, just to briefly touch on, we have a couple of ideas, at least for our initial prototyping. We're looking at machining. Some of this material is fairly easy to machine, so we'll do some kind of a machining. However, moving into large-scale production, we believe we can do an injection molded method of manufacturing, which would be really good for a high turnout situation. So talking about our concepts and some of the benefits we have main one is the prevention of damage to ocular structures by controlling that angle and by controlling the location of injection. This helps to reduce those risks and specifically to allow a non-ophthalmologist or at least a non-specialist to perform these procedures. These can be, initially go to all the retinal specialists and then increase to an ophthalmologist, and then hopefully we're thinking it will allow an NP or a PA to perform these procedures. That's a nurse practitioner or physician's assistant. This, especially combined with the huge rising amount of patients that doctors are going to need to see, will help them kind of deal with this in the future. Some of the technical risks we're looking at with this are surface irritation. So we want to make sure that our devices won't cause any damage to the eye when it's placed upon the eye, that it does not affect the infection rate. There's no increase in the infection rate. That's very important. And then that our structural damage and any piercing of the device are mitigated by our selection of materials. And we can also solve the use of improper usage or negligence by proper packaging and instructions included. So in our DIOVV, we met with a couple of ophthalmologists who gave us their input on this, and specifically, as I mentioned before, with the profile of the device and the patient's comfort in there, and their major things, reducing the risk, idiot-proofing, if you will, the procedure and making it kind of like a really standard kind of same thing every time happening. And we want to make sure that it's the most accurate and fitting the most people. And as I mentioned before, some of the risks that we were looking at is that you can't pierce the material, that there's no damage to the eye. That's a very important one. Our most important thing that we want to make sure to get is that whenever you place this device, that injection point is consistent and accurate. So now Sean will talk a little bit more about our business plans.
Thank you. Yeah. All right, I'll put it on this side. Okay. So I am going to speak to you guys about the reimbursement strategy and also tie it into a lot of the market stuff that we've been hitting on. So as it stands right now, ophthalmologists are reimbursed $125 for the injection itself, excluding the cost for the drugs and things like that. This is down from $200, which it was before 2011. Part of the logic behind CMS decreasing the reimbursement for this procedure is because thousands of these are being performed, so they don't consider it as skilled of a procedure. So as this procedure happens more and more, it could be the case that reimbursement continues to go down. One of the other things to note is that these doctors only make a profit margin of about $30 per injection. So what we seek to do is to move the care to other skilled medical personnel, including MPs, general ophthalmologists, people who are experienced in invasive procedures. And by doing this, even if reimbursement gets cut in half, that would save the system, it would save CMS about $8 million as a conservative estimate every year. Higher estimates would be in the tens to almost $100 million range. If the time spent by the doctor giving the injection is spent doing another procedure that is equally as profitable as the intravitreal injections are now, they will make an extra $62,000 a year on a practice level. We see one of our first areas of entry being these rural doctors, and using that data to show that this device can be effective and then maybe implemented into the less trained practitioner space. Patients have to drive 8 hours to see their retinal specialist who does intravitreal injections every month, puts a huge burden on the patients and their caretakers. Oftentimes, family members have to take a day off of work to go and take their loved one. Oops. Oh no. Sorry, guys. I don't know what's happening. There we go. Cool. So this also ties into our regulatory strategy. This device is likely to be considered a manual ophthalmic surgical instrument. These devices are Class 1 510K exempt. And there is nothing quite on the market like this before. So one of the risks we might encounter would be if the FDA would require us to generate a new product code, which might take some administrative time. Then we also mentioned some of the risks with CMS. If we would have to provide data that would show that this procedure is equally effective with someone other than an ophthalmologist performing the procedure in order to get reimbursement. And then one of the other bodies to consider is the American Academy of Ophthalmologists. There is the potential that giving this procedure would cause kind of a turf war, which we hope wouldn't be able to be mitigated, coupled with the decreasing reimbursement. So doctors already aren't making a lot of money on this procedure, and they are lobbying to get that reimbursement back up. However, if that does not happen, we hope to couple that with the opportunity to make more money by doing other potentially more profitable procedures. So leading into our R&D strategy, we already hit on a lot of these technical and manufacturing challenges. One of the ones we didn't mention earlier was the tolerances that we would have to be aware of that's working on such a small scale. A 30-gauge needle is approximately 0.025 millimeters. Is that right? And we also would manufacture and distribute this product using GMP, and it would be sterile. Some of the milestones include, our first proof of concept. Our R&D stage is going to be shortened, as this device will likely not require any preclinical animal or human trials, we would do it mostly in an animal eye model and then a cadaver eye model. The packaging is also a consideration for us. We're going to be shipping this sterile, and we want the clinician to be able to open the packaging without disrupting their sterile field, be able to place it sterilely, not hit any of the lashes or anything like that. So in summary, we hope to be able to save both the system money, allow ophthalmologists to make more money, and empower nurse practitioners, other ophthalmologists to perform this growing procedure. And we welcome any questions you guys may have, some quick acknowledgments, including our fine professors, Jason White from CardioMEMS, and then Drs. Timothy Olson and Stephen Yap, who are with the Emory Eye Clinic, and they gave us a lot of awesome feedback that helped us choose our design and make certain considerations. Thanks. Questions?
So what did Dr. Olson and Dr. Ye tell you at Emory? What you propose? Did you propose this idea to them?
Yeah.
What did they say?
So their big concerns were the injection site becoming infected and who would assume the risk for those kinds of complications. So if it's the nurse, even if the ophthalmologist who's a specialist is managing the care, if he's not controlling the actual physical injection, there is a concern that, you know, there might be increased complications, and then he would be or she would be responsible for those costs.
How did they feel about someone other than a licensed ophthalmologist?
Yeah. Yeah, very.
Which, you know, that's part of our plan in terms of getting the rural doctors to be able to do it. Somebody who has a knowledge of the body, but isn't necessarily an ophthalmologist, to be able to start the process to show that, because something that really is about this is that the incidence rate of complications is extraordinarily low, like 0.4% or something of that nature. But the actual procedure is incredibly simple. And so they even told us, look, we could teach you guys, or a monkey, to do this in a day.
That's about equitable.
And also one of the things as I mentioned before is another pathway, in addition to the rural doctors, would be working kind of backwards from that of you have just the people who do injections, and then you have retinal specialists, and then you have ophthalmologists, and then you have so you can kind of build up, so maybe you could do, all right, we're starting an ophthalmologist do it, but maybe someone who just doesn't do injections all the time. Yeah. Kind of like slowly building and showing that if an ophthalmologist just uses it, it's safe, it's effective, it's fine, then maybe go on to some, and so you kind of like, it would have to be done in stages, and we also hope that, well, as this huge wave of people comes in who needs this, they're already performing 20 injections a week. More, yeah.
60 to 80.
60 to 80, so 20, sorry, that was about 20 injections a day. So if they're like, I just don't have time to do all this, they may not have a choice but to hand it over to
And
nurse.
I agree with your premise that the future, there's going to be some kind of crash because there's too many patients and not enough practitioners.
I think that they don't see the immediate need, but they do see the need to allowing these people to all get adequate care. And they know that there's not that many ophthalmologists coming in. But the analogy for this case is kind of similar to that of cardiologists versus cardiovascular surgeons with the introduction of stents. They're not doing all these coronary bypasses, and you talk to cardiovascular surgeons, it'll never work. So we're hoping that we'll follow the similar method of adoption.
So the way you see this thing being used is you would have just forceps to open up the lids and then place this thing on there.
Mm-hmm.
Would there be any local anesthesia or anything, like a proparacaine or a topical lidocaine or anything that would be?
Mm-hmm.
Yeah, and that's standard for an ocular injection.
And there are also studies that show that the pressure can have an analgesic effect. So if they push around the ring of the contact, it might be that this is conjecture.
Right.
Yes, this would be in addition to the procedure rather than the supplementing part of it, which also would be easier for them because all they need is one extra step of just.
And this, how would this thing center on the eye?
Right, so it would, two methods. So first it would use the anatomy of the eye. So the lens, well, this isn't the lens, but the eye is symmetrical around its axis, but not, yeah.
We would use a solid contact form for the overall shape so that it can actually conform.
So it's basically like a contact lens with a frame.
Exactly.
Yeah, essentially.
And because that's one of the things we have to be careful of in our material selection is we want it to be flexible enough that it will actually conform to the eye, and that's how contact lenses stay on. They conform to the eye and find that, but firm enough that we have that strength that we need.
What do you have with sliding around?
Yeah, so using the material that conforms to the eye, it's the same way contacts generally stay in place.
But like if you're putting pressure on something to inject, like is there a risk really that it could like slide away?
Yeah, that would be one of the potential failure modes for the technology. One of the alternative designs that we considered would be putting like a crosshairs, having it the whole lens, having it cover this whole region, and then having a crosshairs so whoever's administering the shot could self-center, hold it in place, and then do the injection.
Yeah, so how do you go back and forth and kind of weigh the time costs for actually placing this contact-like device when, you mentioned that obviously it's the surgeon, the ophthalmologists don't have enough time anyway in the first place, and I think you mentioned, if you move to the nurse practitioners instead, but how do you weigh that?
Do you wear contacts?
I do.
How long does it take you to put it in?
Like 5 seconds. But,
There you go.
So what I'm saying is you're adding something extra to their time.
Mm-hmm.
So how do you sell it?
Yeah, so it's the time shift from the ophthalmologist, who's more expensive and could be making money doing other procedures, to a less trained practitioner. So if the nurse is administering the shot, her time costs less than the doctor's. And there's a concern about, added overhead and that cost on the doctor's side, and then making that decision. And that's one of the analyses that we're going to do for your class.
So it's just that, and relatively, as you said.
Two things. From the CPT code, could a nurse use it? I don't know. That's more from my own education. Two, if Clearside is treating the same patients, do you think these would be mutually exclusive solutions?
No, so this device is more targeted at who will be performing the procedure. So this could be adapted for various needles of various sizes.
That was actually part of our, we were considering future technologies, and there's honestly no reason that you couldn't use the Clearside needle with this device.
However, on my understanding of it at least, is location isn't as sensitive on that because you're not actually going into the internal structure of the eye. And the location selection of this, and the reason for that, is it's very important to select that location whenever you're actually violating the intravitreal space, which wouldn't be with the Clearside needle, so location wouldn't be that as big of an issue as it is in this procedure. So while you could theoretically use it under the same one, they would kind of be, if you use that other one, you wouldn't need this.
Yeah, that is also true. And back to your other question, I am not sure about nurses being able to charge to the CPT because they don't do it right now. I do know that the doctors, so sometimes what will happen is if an ophthalmologist has a very rural patient, they will give dose and frequency instructions to the patient, and their local doctor will perform these injections. So it's a little bit riskier for that patient, but sometimes it's worth the travel time, and those doctors are able to charge to that CPT code.
Dr. Olson actually hinted that a PA would be able to because he gave us a list of people, including PAs and other ophthalmologists and optometrists, and the only person that out of that group that he indicated that was legally excluded from being able to do the procedure would be the optometrist.
Mm-hmm.
It's a different training.
Any other question? If not, I'll go last to round up my list. I have a few technical questions. One is, With regard to material usage, you're written PTFE. I don't think PTFE is injection moldable. PTFE is not. Try FEP. That's very closely related to PTFE, just a copolymer of PTFE and another hexafluoropropylene, and that is injection moldable. So FEP, PTFE is only paste extrusion. They can only use powder metallurgy techniques for PTFE. It's very high melt viscosity. So it's not injection moldable. So try FEP. Another alternative is PVDF. There's a newer materials, polyvinylidene fluoride. It's got a lot of the same characteristics of the fluorocarbons like PTFE, but it's got much easier processability, and it can be. A company like Solvay Polymers makes it. So try contacting them. You can get sheets of them. You can get films, all the strips. Those materials they'll provide samples even. So PVDF, FEP, polyurethanes, various grades of polyurethanes, they can be various ranges of softness and hardnesses just by playing the soft and hard segment ratios.
Awesome.
So these are the candidate materials which I think might be lend itself to trials in your, different, then you can zero in an optimum degree of hardness and the characteristics you want. But injection moldability, these are materials that come to my mind. Then I want to sort of talk about, have you thought through in nationalized medical insurance, countries like UK, Canada, where they have national medicine? What kind of reimbursement would you anticipate for this procedure? Would it be easy? Would there be problems strategically compared to US insurance? That's something, even if you're not thought through, I'm just down the line, I'm just letting you know, that's something that you've got to factor in, because if the cost increasing, aging people living longer, all those issues, there's a lot of health economic impact here in this aspect. So just to let you know on that. Think about. And third thing I want to tell you is, to me, this procedure, this whole process and for treatment looks very similar to the epidural treatments right now to pain specialists do. I had myself some years ago. You just go for a back, you have back problem, pain medication. They do a CT scan. It's just a small poke in the right location, more to get the right location, and they put the steroid injection. Maybe you want to check that whole process, the procedure, in terms of the devices they use, under the guidance of CT scan. If there's anything that you can leverage from it, any synergistic features, that might be of value for this project. Just a comment that's going out on
They
that.
don't do that under fluoroscopy, and fluoroscopy is not going to enter soft tissue accurately if you got anything.
Yeah, and it would be tough going through the orbit, but
But
it's worth taking a look.
Yeah, just take a look at that procedure.
It's kind of like targeted injection.
Yeah, targeted injections basically. Targeted, very precisely targeted injection. Because in the epidural, they go precisely between the right vertebrae, the location, then poke that in. And that, believe me, it gives relief. And it's a cost-saving feature too. Because if you don't want to have that, then you're alternative surgery. And this can put off surgery in many cases by 3-4 years, or in some cases longer than that.
Well, look at that.
Yeah. And one more thing that occurred to me is this is an aging disease, so a lot of old people are going to be coming in. If you own this company, it would be in your interest to also come up with an early detection mechanism for it. So how do you detect it early so that you can arrest the progression, the kinetics of the progression rather?
Yeah, and that's one of the things that we actually very initially at very early stages we're looking at is kind of a early detection device. Right now it's fairly considered with just like if you're going for an optical checkup, you can look at the back of the eye. Oftentimes you can kind of see an overaccumulation of what these things are called drusen, which is these kind of yellow fatty deposits. There's lots of them. You're kind of at risk. You can also sort of see a bit of the retina, and there's some new imaging devices out for the retina. Other than that, for wet AMD, they have what's called an Amsler grid test, which is just a series of lines. And if you look at them and they're wavy, danger. But right now, at least in the kind of the earlier, as you mentioned, the earlier you catch it, the better it is. They don't know when dry progresses to wet, so things would be great is if you could know if you were at risk, if you knew when dry progressed to wet, and then as soon as you get wet, treat it.
Yeah, I work for Alcon Labs, which is World Leader in Eye Care. They follow these companies, they follow the disease in all its entire complexity. So that includes the detection, the treatment, everything. So you take ownership of the whole disease. You don't just create one device, one segment. You look at the big picture, be more comprehensive. So that's the approach they take. That's why I'm suggesting they also create devices for detection to help the ophthalmologist, along with the devices for implantation or the procedure, all the other surrounding things for detection, for easier more user-friendly software, the whole package. That's what I'm trying to get you to think about, the mindset. Think of the whole package of all the things that ophthalmologists will need in treating this whole disease in a very comprehensive fashion. The last question, again, my business instincts lead me. There's no timeline. I can't accept anything from any project in the real world without timeline. Nothing, every word spoken has a time associated with it.
We'll include one in our paper.
Please pay attention to that. But other than that, I want to thank all the three teams. My comment is I just wanted to wait till all the three teams are done before passing my judgment. I just want to tell you there's a fantastic effort. It's going to be an evolutionary process, not just through this course, but throughout your lives. And all of us work, we have constantly improved upon, learned. So it's lifelong learning process. But it's just a fabulous start. You guys have got started off. The range of thinking, the solution approaches, the breadth of thinking you have displayed is really superb. And please keep in mind all the comments everyone has made and go along as you go along. Every semester, as I told this class, but I'm letting everybody know, every semester we're going to have this kind of a wrap-up event. At the end of the semester, a presentation for the project, each of the teams with the social, with all the other people. Hopefully, next 2 semesters we'll arrange on a day when more of the external faculty